Hi and hello dear friends, welcome back once again to our channel Vagai Academy of Mathematics, and this playlist is where you can find video lessons for CBSE Class 11 Applied Mathematics, and we are following our standard book ML Aggarwal and Neeraj Raj Jain. This session we are about to solve exercise 4.1 and it is based on the topic mensuration. And if you see here we have got more problems and they are all based on all 2D shapes. So you'll come to get questions based on these following shapes here. So you take it, here you will have questions based on triangles. So we see different types of triangles are there, right? So you've got equilateral triangle, isosceles triangle, right angle triangle, scalene triangle. So based on all these concepts, you will come to get questions here. And next is you will come to have questions based on circles and a part of a circle. Part of a circle means we call it to be a sector, right? So a sector is going to be out of a circle. So all those things. So based on that, we have questions. And next, we also have questions based on different quadrilaterals. So quadrilaterals means any four-sided region. You will be knowing about it. So different quadrilaterals like rectangle, square, parallelogram, rhombus, trapezium. So you will come to get questions based on these things. So as I told, we have got many problems here. We are going to solve all those problems one by one. I'm not going to give you all the concepts here itself, so it would take more time. So we will directly get into the problems itself, and wherever those concepts necessary, we will see there along with the problems itself, or otherwise we'll just see the concept which is based on that problem and then we'll come to solve the particular problem. Okay, so let's take this particular order in order to solve the problems. So yes, now we'll start the session. Yeah, let's get into exercise 4.1. Yes, let's start from question number 1. So here question number 1 is based on triangle. So finding the area of a triangle. So first of all, let's quickly recall what about the area of a given triangle. Okay, so we all know about a triangle, right? So we will have three sides. And how do you calculate the area of a triangle? So see here, whenever we have a triangle and if we are given the base of the triangle and height of the triangle, then area can be found using the formula area is equal to half into base into height. So B is this base and H is going to be the height, perpendicular height. I mean this base and that height, they both should be perpendicular. I mean like they should be at 90 degrees, right angle. Okay, so this formula to be used. Whereas if we are given the three sides of the triangle, let's say the three sides are going to be A, B and C, then we will have to use this formula, the second formula, to calculate the area. Now see this formula, this says area is equal to square root of, okay, a big square root of a product we have inside S into S minus A into S minus B into S minus C. So it's very clear that this A, B, C are going to be the three sides. But what about that S? That S is nothing but the semi-perimeter. Okay, we call it to be semi-perimeter. That is, the perimeter of this triangle is going to be A plus B plus C. And semi-perimeter means half of that, which means S is nothing but A plus B plus C whole divided by 2. Now using these two formulas are what we are going to solve the first problem. So let's now get into the question. Find the area of the triangle whose sides are 34 centimeter, 20 centimeter and 42 centimeter. So now if you see this question, we are given the three sides itself, is it or not? So let's take a note, and also we'll do something. We'll take the three sides to be A, B and C respectively. Okay, so A is what is 34 centimeter, then second side B is 20 centimeter, and third side C is going to be 42 centimeter. So what are we supposed to do now? We need to find the area of this triangle. Okay, so when we have three sides, we can use this second formula to find the area, is it or not? But before that, in order to use the second formula, we should first find out the value of S. So let's try to find the value of S now. So S will be nothing but the sum of the three sides divided by 2, is it or not? So A plus B plus C by 2, which means I will have 34 plus 20 plus 42 divided by 2. So this will give you how much? So just add these numbers. I will be getting 34 plus 42 will be 76 plus 20 will be 96. 96 by 2 will give you 48. So 96 divided by 2 is what we will be getting. So this gives you 48 centimeters. So we got the value of S successfully. Now we can find the area. Okay, so area will be nothing but Now we can use this formula, square root of s into so and so on, right? So square root of, now what about s? S is what is 48 multiplied by, now what about s minus a? So we have s minus a there, right? So s minus a will be nothing but 48 minus 34. So 48 minus 34 will be 14 multiplied by, next s minus b, 48 minus 20, this gives you 28, and next third one, s minus c, s minus c means 48 minus 42, this gives you 6. So we need to carefully calculate this answer, that will give you the answer for the area, right? So this will be equal to, let us not multiply or complicate the process. Let's just try to rearrange or just rewrite the same product in a different way. Okay, fine, yes. So have a close look here. Now what I'm going to do is, yes. Now I'm just going to break the numbers. That's it. Okay. Now look at this. 48 can be written as, 8 6 are multiplied by this 14 I'm writing as it is. Okay. Listen very carefully. This 48 I'm writing as 8 6 are. This 14 I'm writing as it is, I'm just dropping it down. This 28 I'm going to write it as 14 into 2, and again this 6 I'm going to write as it is. Okay, fine, yes. So only these two numbers I am rewriting like this. Okay, yes. Now this will be again equal to, again a whole square root of. Now what next I'm going to do is, I'm going to pair the numbers. Okay, fine, yes. I'm going to pair the numbers. How I'm going to pair is, now listen very carefully again. I have an 8 here, I have a 2 here, right? Now 8 2s are will become what? 16. 8 2s are will become 16 multiplied by, see here, I'll just connect it again. 8 2s are, this 8 multiplied with this 2 gives you 16. And what next I'm going to do is, hereafter I'm going to just easily write the numbers, because you see here I have a 6, here I have a 6. So 6 into 6 will be nothing but 6 square, right? The 6 square itself, and then multiplied by here 14 and 14 square. I'll write like this. Now it's going to be very easy for me to find out the answer. So area will be now equal to, just now see this expression, I have a square root of 16 into 6 square into 14 square. I can easily take the square root, is it or not? Root of 16 will be nothing but 4 into root of 6 square is 6, root of 14 square is 14. That's it. Now I can easily multiply these numbers to get the answer. So what will this gives you? 4 6 is already 24. 24 into 14 I need to do. Okay. So let me take this space. So 24 into 14. So this will be nothing but 4 4s are 16. 1 is the carry. And then I can do 2 4s are 8. 1 4s are 4. So 8 plus 4 will be 12. 12 plus 1 is 13. 1 carry. Again 2 1s are 2 plus 1. 336. So 336 is going to be the area, but we need to write it along with the units. That's where we need to be very careful. See here, the units used for the lengths are going to be what? Sides are going to be centimeter. So the answer I will be getting for area will be in square, centimeter square units. Okay, so centimeter square, this is going to be the area. Okay, so successfully we found the answer. Okay, find the area of the triangle they have asked. We have found the area of the triangle, but we have something more there asked in this question. Let's continue and see. Hence find the length of the altitude. Okay, fine, yes. We need to find the length of the altitude. Altitude is nothing but height. Okay, so the other name used for altitude is nothing but height. Okay, height. Okay, let me just note it here itself. Height corresponding to the shortest side. So that means we need to find the height that corresponds to the shortest side. That is, if the shortest side of this triangle is taken as the base, then what would be the corresponding height? That's all. This is going to be the question. So this we can very easily calculate. How we can calculate? Now again, just see the formula that connects the area and height of the triangle. So that's the first formula, right? So half into base into height. So area is equal to half into base into height. Now let's use this formula to get the height. Okay, height. Okay, yes. Now what I am going to do now is, here I am going to take the shortest side to be the base. So here what is the shortest side among the three sides? This B is the shortest side. Okay, so 20, because the other two numbers are bigger. So this is the shortest side. So I'll take B is equal to 20. This is my base. And then height is equal to what? We don't know the height. That's what we need to find now. Okay. Now let's use the area formula. So what is the area formula? Area formula is half into base, which is 20, into height is equal to, what is the area? Just now we found the area, right? 336. So 336. I'll just put a line so as to not have any confusion. Okay. Now I need to find the height. If I solve this, I can easily find the value of height, is it or not? Now we can easily solve this 2 and this 20 exactly 10 times. So I'll be having h is equal to 336 by 10, which is exactly 33.6 centimeter, because we are finding height. So height will be in simply units alone. Okay, so we should not put square and all here, because we are not finding area or anything. Okay, height, we are finding the height, it's like a side, length, anything like that. Okay, fine. So it's a single dimension quantity. So height is 33.6 centimeters. So this is going to be the height. Okay, so successfully we found the answer for both the data that is asked in the question. Okay, so one question, but we need to find the area. We found it, 336 centimeters square is the area of this triangle, and the height corresponding to the shortest side is 33.6 centimeter. Both of the things we got it here. So these are the answers for your question number 1. Next we have question number 2 with us. The sides of a triangular plot are in the ratio 3:5:7 and its perimeter is going to be 300 meters. Find the area. So we are given about the three sides, ratio is given, and also the perimeter of the triangle is given. So these two things are given, we need to find the area. Very simple question only. Okay, so again what I'm going to do is I'm going to take the three sides as A, B and then C. And note that we are given the ratio of the three sides, 3:5:7. So in that case, what I'm going to do now is, let me take the three sides to be 3x, 5x, 7x, where x is some multiplier constant. Okay, yes. And now we need to find the area, correct? And in between, we also have the perimeter is given. The perimeter is 300 meters, that is given. Okay, yes. Now before that, what I mean by perimeter? Perimeter is nothing but the sum of the three sides, is it or not? So that means A plus B plus C should be what is equal to the 300, correct? Yes. Okay, fine. Now that means I can use these expressions 3x, 5x and 7x. I can just put it here. So when I put it here, what happens? 3x plus 5x plus 7x will be equal to 300. So which means just add the numbers here itself. So it will give you 15x, is it or not? So 15x is what is equal to 300. That means x will be equal to 300 by 15, which will be exactly 20. So now I got the value of x is equal to 20. Now simple, I can just put x is equal to 20 here to get the three sides. So I will be getting A is equal to 3 into 20, which will be 60. Remember, the perimeter is given in terms of meters. So our three sides will also be in meters only. Okay, A is 60 meter. B is 5x, right? So 5 into 20, which will be 100 meters. And C is 7x. 7 into 20 will be 140 meters. That's it. Now we got all the three sides. Now the only thing is we need to find the area. So to find the area, we can again use the same formula. What formula? We can use what? We can use root of s into s minus a into s minus b into s minus c. We can use that formula itself to find the answer. Okay, so let me rewrite that formula once again just for you to recollect. So s into s minus a into s minus b into s minus c. But in between, we need to find the value of s first, is it or not? So only when I find the value of s, I will be able to find the area. So let me take this space to find the value of s. So s will be equal to a plus b plus c by 2, is it or not? So a plus b plus c by 2 will be, already we have the value of a plus b plus c, it is going to be 300. So just we need to divide 300 by 2. So this will give you 150 meters. So s is equal to 150 meters. That's going to be the value of s. Now I can use it here to get the answer. So this will be, area will be equal to square root of, now s is 150. So 150 multiplied by, next I have s minus a. So calculate the values very carefully. S minus a will be 150 minus 60, which will be 90. Next is s minus b, 150 minus 100, which will be 50. And s minus c will be 150 minus 140, which will be 10. That's it. Okay. Yes. Now what next I'm going to do is, look at here very carefully. What I'm going to do is, I'm just going to segregate all the tens from our numbers. Okay, fine. Yes. So I will be just rewriting this as 15 into 9 into 5 into 10 power 4. I can write it like this, right? So I don't think like you will have big confusions here. Why? Because here I have a 10, here I have a 10, here I have a 10. I'm just combining, or I'm just collecting all the tens and I'm just multiplying here. Okay, so I will have totally 4 tens here. So that's the reason I have 10 power 4 here. Okay, remember 10 power 4 is nothing but 10,000. Okay, Now what next I'm going to do is, first I will remove this 10 power 4 out of the square root. Now 10 power 4 is 10,000. When you take square root of 10,000, it will be nothing but 100. So I will simply have 100 into square root of. Now I will be having only these three numbers inside the square root. I hope you understand this. Understand? Okay, yes. Now again I'm going to rewrite these numbers. See how I'm going to write. First I will just break this 15 like 3 into 5. 3 into 5, and I will write this 9 as 3 square itself, and I will write this 5 as 5 itself. Okay, fine. Let me continue it here. So area will be equal to, I don't have space here, enough space here, I'll continue it there. Okay, so from this step we are coming here. Now here we had 100 into square root of okay, yes. Now we have here 3 into 5 into 3 square into 5, correct. Now I can collect these two 5s also. I can write it as 5 square. Okay, so I'll write this as 5 square into, here already I have a 3 square into, here I have one single 3 without any pairs. I have a single 3 here, so 3. That's it. Now once again I can even remove this 5 square and 3 square also out of the square root. So when I do that, I will be having what? Root of 5 square will be 5, root of 3 square will be 3, and this time I will only have a root 3 inside this. Here I mean inside the square root I will have only this 3, so square root of 3. Okay, yes. So now we have taken all the numbers out of the square root. We have taken the square root, and we are finally left with root 3 alone. Okay, yes. So now what do you have? 100 into, this is 5 3s are 15 into square root of 3, and it is also given there in the question itself. We can take the value of square root of 3 as 1.732. so just substitute it here, 1.732. now once I multiply these numbers, I can easily get the answer. That's it, very simple. Okay, yes. So let's carefully multiply these numbers, because we have got decimals also, right? So let me do something. I will first multiply 15 into 1.732. See the way how I am going to multiply this. So 15 into 1.732, right? First I will multiply 10 into 1.732. So I'll just multiply 10 into 1.732. Okay, so 10 into 1.732 will give me, so 17.32. Correct, just one decimal place to the right hand side, right? So 17.32. and next I'm going to multiply 5 into 1.732. so 5 into 1.732 will be nothing but exactly half of this value, because this is 10 into 1.732. I want 5 into 1.732. It's exactly the half of this. That's it, right? So half of this number will be nothing but 17. Half will be 8. So I'll have a 1 carry here. And then 13 half is 6. Again 1 carry here. 12 half is 6. So 8.66. Now I can simply add these two values to get the answer for 15 into 1.732. That's it. Nothing else. Okay. Now 2 plus 6 8. 3 plus 6 9. And 17 plus 8 will be 25. So I have 25.98, right? So 100 into I will have 25.98, and now I will finally have 25.98 multiplied with 100. This gives you 2598. So 2598. What about the area here? Area should be in square units, and see the units here. Here the units given are meters, so that means our answer will also be in meter square or square meter. So final answer is 2598 meter square is going to be the answer for your second question. Into question number 3 here. If the perimeter of an equilateral triangle, okay, remember this question is based on equilateral triangle. So the perimeter of an equilateral triangle is 36 centimeter. Then calculate its area and height. Very simple question, and also a straightforward question we have here. And as I told, this question is based on an equilateral triangle, is it or not? So we should be knowing about the nature properties of equilateral triangle. So we have a triangle when all the three sides of a triangle are going to be equal. That is what is we call it to be an equilateral triangle. Okay, fine. And what is so special about equilateral triangle? The sides are equal, and also the three interior angles are also going to be equal. Okay, so when we have such a triangle, what we can do is, let's just take the sides to be A. Okay, so A, because all sides are equal, I'm just taking the side to be A. Now we have got the formulas to find these measures. First one is perimeter. So what about the perimeter? Perimeter means we have to add all the three sides. So A plus A plus A will be 3A. And what about the height? Height will be nothing but square root of 3, I mean root 3 divided by 2 into a. This is a formula to find out the height. Okay, height means altitude, height, whatever way we can call it. Okay, so height means the measure that is drawn from the opposite end to the base, but it should be in a perpendicular way. So that is what is height, root 3 by 2a. And the area, formula to calculate the area will be root 3 by 4 into a square, where this a is going to be the side of the equilateral triangle. Okay, now we are going to use these formulas or what to solve this problem. So let's just check this question. Here we have the perimeter of an equilateral triangle is given to be 36. So perimeter is 36 in the sense we can clearly understand that 3a is equal to 36, which means a is equal to 36 by 3, 12 centimeter. Is it or not? Because it is given in centimeters, so side will also be in centimeters. So side of this equilateral triangle is 12 centimeter. Okay, fine. Next we need to find what? Calculate the area and also the height. Okay, first we'll calculate the height. We'll calculate the height first. Okay, so height will be what? Height is equal to root 3 by 2 into a. Correct? Root 3 by 2a is going to be the formula. So root 3 by 2 into a is 12. Just now we found it. So this will be nothing but, I can cut this 2 and 12 6 times. So I will happen to get 6 root 3. So 6 root 3 is going to be the height. And let's try to simplify, right? Okay, so root 3, as usual, we will take root 3 as what? Root 3 is equal to 1.732. Let's take the same way. So 1.7, so 6 into 1.732. 1.732 will actually give you how much? So we'll carefully multiply the numbers. So when I come to multiply the numbers, I will be getting 6 into 2 first. Okay, so this will be 6 2s are 12, 1 carry, 6 3s are I will have 6 3s are 18 plus 1, 19, again 1 carry, 6 7s are 42 plus 1, 43, and finally 6 1s are 6 plus 4, 10. So 10.392. So we can take it as approximately 10.4. We can take it as 10.4. I mean, like, I'm rounding it off. So I'll be getting 10.4. So height of this equilateral triangle is going to be 10.4 centimeter, because we are finding height, it's going to be centimeters. Okay, so 10.4. So we found the height. So height is 10.4 centimeter. That's done. And next is we need to find the area also. Okay, height is found and area. Next is area is going to be root 3 by 4 into a square. So which means root 3 by 4 into, what about a here? A is 12. So 12 square, which means 12 into 12. This is going to be the area. So I'll carefully cancel these numbers also. When I try to cancel it, I will be having 6 times, again 2, 6 times. So I will have root 3 into 6 into 6. This is what I will be having, because I cancelled with 2 tables twice. So this will be going off, and here 6 times, 6 times. Okay, fine. Now you see here, I already have what? Root 3 into 6 into 6. So this is nothing but 6 root 3 into 6. Is it or not? Already we have the value of 6 root 3 here itself. 6 root 3 is what we found here. Is it or not? 6 root 3 is what we found here. We simplified it to 10.4. So 10.4 into 6. So 10.4 into 6 will actually give you, it will give you 4 6 are 24. So 2 is the carry. Again 6 zeros are 0 plus 1, 2. So 2.4, and 6 ones are 6. So 62.4 centimeter square, because we are finding the area. So centimeter square. So yeah, both the values we found it now. So area is going to be 62.4 centimeter square, and height of this equilateral triangle is going to be 10.4 centimeters. So these are going to be the answers for your question number 3. Now we have question number 4 with us. This is based on an isosceles triangle. So basically we need to know some properties of isosceles triangle. So this triangle, you will have out of the 3 sides, any 2 of the sides to be equal. So such a triangle is what we call it to be an isosceles triangle. Now let's come to the question. Now find the area of an isosceles triangle whose equal sides are 12 centimeter each, and the perimeter is going to be 30 centimeter. So they are given that there is an isosceles triangle, and they are given the 2 equal sides to be 12 centimeter each. So that means here you see this triangle. I have drawn an isosceles triangle here, and this triangle is ABC. Let me take the 2 sides AB and AC to be the equal sides. So which means, as per question's condition, this AB is 12 and AC is also 12. Is it clear? Okay, fine. And now what next we have? We are given the perimeter of the triangle is going to be 30 centimeter. Okay, so perimeter is 30 centimeters. So this is also given. And finally, what is that we need to find? We need to find the area of this triangle. That's going to be the question. And while solving this question, we may need the value of square root of 15. So that's why I have noted this in prior itself. So square root of 15 is going to be 3.873. I've just calculated and noted it in prior. Okay. Yes. Now coming back. Now we have perimeter is 30 centimeter. We all know clearly what is perimeter. Perimeter is nothing but the sum of the three sides. So that means this 12 plus this third side. I mean this base is what is going to be 30. Is it or not? So let me take it to be like A plus B plus C is 30. So that means 12 plus this C is going to be 30, which means I will be getting the value of C to be how much? C will be equal to 30 minus this 24, because 12 plus 12 gives you 24. So 30 minus 24 will be 6. So third side will be nothing but 6 centimeters. So that means we got all the three sides. So they are going to be 12 centimeter, 12 centimeter and 6 centimeter. Okay. So let me take them to be A and B. So 12 cm, then 12 cm and 6 cm. So let's take this way. Fine. Okay. And the next point is we need to find the area, right? So let's again use this semi-perimeter formula. I mean S formula itself to get the area of this triangle, because here also we have the three sides are given, right? So we have readily available the three sides of the triangle, so we can better use that same formula itself. So area is equal to square root of S into S minus A into S minus B into S minus C. But here we need to find the value of S first, so we'll quickly calculate it. It's very easy. So S is nothing but what? Semi-perimeter, that is A plus B plus C whole divided by 2. Already we have A plus B plus C is 30. That means S will be 30 divided by 2. So 30 by 2 will be 15 centimeter. Okay, all right. Now we can just substitute it here to get the area. So area will be equal to square root of. Now do it carefully. First we will have S. So 15 into, next S minus A, 15 minus 12, which will be 3 into S minus B, that is again 15 minus 12, 3 into, and S minus C, which means 15 minus 6, that will be 9. Okay, yes. Now this will be equal to square root of, now see here carefully, 15 into, here I have 3 into 3, this is 3 square, and again I have 9, this is again a 3 square. So that now if I remove it out of the square root, I will be getting what? So let me continue it here. Okay, so I will be getting area is equal to, let me remove these two, 3 square out of the square root. So I will be having this 3 square, when coming out of the root, it comes as 3. This 3 square also comes out as 3, and I will be left with only square root of 15. So my answer will be 3 3s are 9 into square root of 15. And just now we have noted the value of square root of 15, right? So 9 into root 15. So root 15, I will just substitute this value here. So 3.873. Now we will do this calculation, that will give you the answer. So 9 into 3.873 will be giving you 9 3s are 27. So 2 is carry. 9 7s are 63 plus 2 65. 6 is carry. 9 8s are 72 plus 6 78. So 7 is the carry. And finally 9 3s are 27 plus 7 34. So 34.857. Okay, let me write it clearly. So 857. Okay, and when you round it off, we can round it to 34.86, because rounding to the two nearest decimals, so in just 2 digits, so 34.86 centimeters square, because we are finding the area, right? So area will be equal to 34.86 centimeters square is going to be the answer for your question number 4. Next we move on to question number 5. This question is again based on isosceles triangle only. So here, to solve this problem, we need to know two other important properties. One is based upon this isosceles triangle itself. Okay, so let's have a quick visit of what is that property. Now whenever we have an isosceles triangle, so like this, we already know that we have the isosceles triangle, two sides will be equal. So I'm taking here, for this triangle, I'm going to take this two sides AB and AC are equal. And now this BC is like our base. Okay, fine. Now when I try to draw a height or an altitude corresponding to our base, now what will happen is, this height will exactly bisect your base. Bisect means it will divide it into two equal parts. So two halves it will divide. Okay, so this is one property we need to know. And the other important thing is, Now when I try to draw it like this, you can clearly see here there is a right angle formed, is it or not? So that means you will be able to see a right angle triangle here, is it or not? Not only here, so left hand side and also your right hand side. So your entire this triangle, this isosceles triangle will be getting divided into two equal sides of two equal parts of right angle triangle, two equal right angle triangle. Okay, fine. So such two right angle triangles will be able to see. So right angle triangle means we'll have to recall Pythagoras theorem also, because we need to use Pythagoras theorem also to solve this problem. So these are some small things we need to revise before we get into this problem. Now we will see the question. So here our question is, if the area of an isosceles triangle is 60 centimeters square, so given the area is 60 centimeters square and the length of each of its equal sides is 13 centimeter. So out of the three sides, there will be two equal sides in this isosceles triangle, right? The two equal sides are what is given to be 13 centimeter each. So now we'll come to our triangle. In our triangle, we have just taken these two sides, right? This AB and AC to be the equal sides. So let us note it here itself. So these two sides are what? 13 and 13. Okay, 13 centimeters. Okay, fine. And what also we are also given the area. Okay, so area is 60 centimeters square. So area is 60 centimeters square is given. That also we will note it here itself. Fine. Now what is the question here is, we need to find the base of this triangle. This is going to be the question. So base, I'm going to take it as B. And now as I told, we are going to drop a line here. This line will be the height, and let me take this base as, for a comfortable way to do the problem, let me take this base as 2x. I'll take it to be 2x. Now listen very carefully. Now the moment we draw this height and we took this as 2x, now what will happen? This height will bisect your base into two equal parts, right? So bisect itself means it will divide into two equal parts. So this entire base will now become x and x here. You understand that, right? So this portion will be x and this portion will be another x, so that this entire thing will be 2x. So this is a point we need to note. And now is where we need to concentrate on the right angle triangle. Now you see here, we have formed a right angle triangle here, is it or not? With the three sides h, x and this 13. Okay, and remember that this 13 will now act as the hypotenuse of our right angle triangle. Okay, now I am going to use Pythagoras theorem. Why? Because I will be able to represent this h in terms of this x. That's why. Okay, now listen very carefully what I am going to do now. Here, when I now try to use Pythagoras theorem for this triangle, the right hand side triangle, what happens is we will be having h square plus x square is equal to, right hand side will be this hypotenuse, which means 13 square. And now I can rewrite it as h square is equal to 13 square will be 169 minus this x square, and now h will become square root of 169 minus x square. Okay, fine. Yes, so this is what we'll be getting. So we have now written this h in terms of x. This is done. Now let's come back to this area data which is given there in the question. Now area is given to be 60, right? Now what about the area of a triangle? Now we are now seeing this problem with respect to height and base. So that means we can use half into base into height. So half into. Now what about base? Base of our triangle is what? Base is, as per our assumption, it is going to be 2x. So 2x multiplied by, what about height of our triangle? Height, just now we have represented in terms of x itself. I am noting this expression itself here. So square root of 169 minus x square. Now this is what is equal to 60. Correct? Okay, clear? Now when we try to solve this equation itself, we'll be able to get the value of x, and from there we can tell what is the base of our triangle. Very simple. Okay, now we'll try to simplify this. I can cut this 2 and 2 first of all. So I'll be left with x into square root of 169 minus x square is equal to 60. So this is what I'm left with. Now I need to solve this equation to get the value of x. Now if you look at this equation, this looks a bit complicated, right? So let us not complicate the process. Let's try to solve this equation as easy as possible. Okay, in an easy way, we'll try to just solve this equation. Now look at very carefully. I have x multiplied with another what is the expression in terms of x to get this product to be equal to 60. That's it, right? So let's do a very simple thing now. Let's try to factorize this 60 itself. Let's try to factorize 60 itself and check which possible pair is giving you or satisfying you this condition. That's it. Okay, fine. Yes. So I'll start from basic 1 itself. Okay, so 1 into 60. We'll check this pair 1 into 60. Just take x as 1 here. Okay, listen very carefully what I'm doing. Just take x as 1 and check whether you are getting this expression square root of 169 minus x square. Check whether you are getting this as 60. Is it possible? No, when you take x as 1, now what will happen? This expression will give you square root of 169 minus 1 square, which will be square root of 168, which will not be equal to 60. So that means this is not the correct pair. We can reject this. Likewise, we'll just test it. Okay, 60 is not a very big number, right? We can easily test it. So just few attempts. Okay, next I'll take 2 into 30. Because after 1 into 60, the next pair will be 2 into 30 only. Okay, so this way we'll just try in this order. Okay, so 2 into 30, try taking x as 2. So here we'll be getting root of 169 minus 2 square. That will be nothing but root of 169 minus 4. So no, it will not give you. This pair is also rejected out. So next is 3 into 20. Just check this pair. Take x as 3 here. X is 3 means this will give you root of 169 minus 3 square, which is 9. So root of 160. No, this again is not working. Next I will take 4. 4 means 4 into which number will give you 60? 4 into 15 will give you 60, right? So take x as 4 here and check it. So x is 4 means here I will be getting root of 169 minus 4 square, which will be 16. So 169 minus 16 will be 153. No use. So again rejected. Next I'll go for 5 into 5. 12s are 60, right? So 5 into 12. Let's take this pair. So let me take x as 5 here. So when I take x as 5, here also what happens? Square root of 169 minus 5 square. So what about 169 minus 5 square? 169 minus 5 square is 25. So 169 minus 25 will give you root of 144, which is exactly equal to 12. And that is what we have as the other number. So successfully we happen to check this pair is exactly working out here. Is it or not? So that means x can take the value 5, or it can be the other way, right? X can even take the value 12. Is it or not? X can even take the value 12. Why? Because if 5 is working condition, this condition is satisfied, then 12 will also satisfy this condition. Just take it. Let's take x as 12 here and check it. Okay, take x as 12. Now what happens is square root of 169 minus 12 square. So 169 minus 12 square will be 169 minus 144, which will be square root of 25, which will be 5. That's it. Okay, so when you take x as 5, you will get the other number as 12. When you take x as 12, you will get the other number as 5. So exactly these two numbers are satisfying. So x can take any one of these two values. Okay, that means x is either 5 or 12, which means what about our base of the triangle? Base of our triangle is, we have already just taken it to be 2x, right? So base can be what? When x is either 5 or 12, our base can be either 2 5s are 10 centimeter. It can be either 10 centimeter or otherwise base can be 2 12s are 24 centimeters. So our base can be either, okay, either 10 centimeter or it can be 12 centimeters. So these are the two possible answers for your question number 5. Next we have question number 6 with us. If the perimeter of a right angle triangle is 60 centimeters, so they gave there's a right angle triangle and for which the perimeter is going to be 60 centimeters. This is what they gave, and its hypotenuse is 25 centimeter. So they also gave about the hypotenuse of this right angle triangle. So hypotenuse is going to be 25 centimeter. This is also given here. Okay, yes, fine. Now finally what they asked here is find its area. Now we need to find the area of this right angle triangle, and we are very clear about how to find the area. So area of a triangle is going to be half into base into height. Now look at here I have drawn a right angle triangle ABC, and if you see here only angle B is what I have taken to be 90 degrees. So that means obviously what happens, this BC will be the base and this AB will be the height. Okay, yes. So let me take, this is base and this is height. And now this AC will be the hypotenuse, and if you see hypotenuse is given in the question itself, hypotenuse is going to be 25 centimeter. Okay, all right. Now we need to find the area. So now what I'm going to do is I'm just going to take this base as some x. I will take the base as x. Now see what will happen. Since we know that perimeter is 60 centimeter, what I can do it from here is I can very well tell this base, that is x, plus this height, which will be h, will be equal to, sorry, plus this 25. So the third side, right? Because the three sides are going to be x, then this h, then this 25. Okay, the addition of these three sides will be equal to 60 because perimeter is given to be 60. So I can add the sides and equate it to 60. Now what I will get for h is the height will be, what I will be getting is this 60 minus this 25 minus this x. So what we will get here, 60 minus 25 will be 35. 35 minus x. So we will get h is equal to 35 minus x. So let's note it here. So h is equal to 35 minus x. So just to represent our base and height in terms of a single variable is what I just did this. Okay, fine, yes, nothing else. So now base is x for us and height is 35 minus x for us, and hypotenuse is going to be 25. That's it. Okay, now we need to find the area. So that means if at all I try to find the value of x, I can easily tell what is the base and what is the height, and with that we can easily tell what is the area of this right angle triangle. That's it. Okay, this is going to be the simple plan. Now look at here, our triangle is it is a right angle triangle. So that means we can very well use Pythagoras theorem, is it or not? So we will just use Pythagoras theorem and try to relate all the three sides. What we will be getting? We will be getting here 35 minus x the whole square, then plus this one base x square will be equal to what about the hypotenuse? It is 25, so 25 square. This is what I will be getting, right? So this is what I will be getting when we use Pythagoras theorem for our right angle triangle. So sum of squares of these two sides will be equal to the square of the hypotenuse. So I equated this. Now let's just try to expand this and solve it carefully. Okay, yes. Now this side if I expand, I will be getting what? 35 minus x the whole square will become 35 square. 35 square will be 1225 minus 2 into 35 into x, because minus 2ab, right? So 2 into 35 into x will be minus 70x plus b square, that means plus this x square. So I will be getting plus x square, again a plus x square is equal to, now see the right hand side. Right hand side I have 25 square. 25 square is nothing but 625. Is it or not? Yes. Yeah, let's continue this. Let's continue. Now I will be having here 2x square. Okay, 2x square, because x square plus x square will become 2x square. Here minus 70x. Then what I will be having? I will be having plus 1225, right? So plus 1225. This 625 comes to the left hand side. So now what happens is we will have 1225 minus 625. That will be together giving you how much? It will give you how much? So 1225 minus 625 will exactly give you 600. Is it or not? Plus 600 is equal to, right hand side will have only 0. That's it. I am trying to bring this 625 to the left hand side itself, so that I am getting this. Okay, I am just subtracting numbers. I am getting plus 600. Now see this entire equation, I can divide the entire equation by 2. So when I try to divide the entire equation by 2 on both the sides, left hand side I will be getting x square minus 35x plus 300 is equal to, right hand side will be again 0 only. That's it. Okay, so now finally we got a quadratic equation, a very simple, very easy equation, right? We can just very easily solve this by factorization itself. So I got a quadratic equation. So here the constant term is plus 300, right? So let's try to factorize the numbers. Okay, let's try to factorize 300. And how we have to factorize? We should factorize this 300 in such a way that the sum of those two numbers should be what? Minus 35. That is, the product should be 300 plus 300 and sum should be minus 35. Is it or not? So in what way we can do? So we can do it like 10 into 30. 10 into 30 will not give you 35. So we can go for a little bit higher numbers. So I can go for 15. So 15 times, right? So 15 into 20 will give you 300. But to make our product to be positive, I can take both these numbers to be negative. Okay, minus 15 minus 20. So I can take those two numbers like that, so that I can very easily factorize this equation as x. What about one number? Minus 15. And again x, what about the other number? Minus 20. So x minus 15, x minus 20. So these are the two factors. Now when I solve this, I will be getting x is equal to either 15 or x is equal to 20. So I get two values for x, either 15 or 20. Both these values will satisfy our original equation. Okay, and remember one more thing, here we try to solve for x. Actually what is x here? X is actually, it represents the length, correct? It represents a side or a length of a figure. That's all, right? So in that sense, if at all I get positive values, I can consider that value. But if I come to get a negative value, means side value cannot be a negative number, is it or not? So that time we can reject it. If I come to get a negative number, negative value, we can reject it. But both these are positive values only, right? So we have to consider both the values here. We should not reject anyone. We have to take both the values. Now one by one we will take, okay. Now if x is 15 means, now what is the meaning? When x is 15 means, now this will imply what? Base is 15, correct? Because base is what is x, so base is 15. And what about height? Height will be what? 35 minus x, because that is our assumption, right? That's what we got here, right? So height will be 35 minus x, so 35 minus 15, so 35 minus 15 will be 20. So this is what we will get. Now on the other hand, if I take x as 20, now what happens? Base will become 20 and height will become what? Height will become 35 minus 20, which will give you 15. But either way, you see the values. If base is 15, height is 20. If base is 20, height is 15. So which means what we are actually here we need to find the area, right? So area of the triangle is what we need to find. Area of the triangle is going to be half into base into height. So our values, whatever pair we take, it won't disturb the answer, because the values are the same, right? They are just interchanged, that's all. The values are interchanged, but the numbers are still the same, so it won't affect the answer. So half into whichever product, I mean like whichever a pair we want, we can take it, that's it, okay. So both will give you the same answer. So 15 into 20, I will take this. So this will give you half into this 20. I can cut up to 10 times, 2 tens are 20. Now I have 15 into 10, which will be 150. So area will be 150. Now what about the units? Units will be centimeter square. So 150 centimeter square is going to be the answer for your question number 6. Now moving to question number 7. Here we have the sides of a right angle triangle containing the right angle are 5x centimeter and 3x minus 1 centimeter. So this is what is given. So that means we have a right angle triangle. Here also we have drawn a right angle triangle ABC, and here angle B is the right angle. And what is that they are given here is the sides that containing the right angle are. That means what? They are talking about these two sides only. That is AB and BC, because these are the two sides that is sharing, or they are having the 90 degree. Is it or not? 90 degrees what is right angle? Okay. So here only we have the 90 degrees. So they are talking about these two sides only. So what about these two sides? They are going to be 5x centimeter. So let me take this height as 5x and 3x minus 1 centimeter. So base, I'll take this to be 3x minus 1 centimeter. Okay, yes, fine. Both are given in terms of centimeters only. Now what is the question? Calculate the length of the hypotenuse. So we need to find the hypotenuse of the right angle triangle if its area is 60 centimeters square. So they also gave you the area. So area is given to be what? 60 centimeters square. That is also given. So we are given these two sides in terms of x, and we are given the area. We need to find the hypotenuse. Very simple question only. Let's try to carefully solve this problem. So let's start from the area information itself, right? So area we all know very well. Area is what? Half into base into height. Correct? Half into base into height. This is the formula. So here also half into, what about the base? What about the base of our triangle? It is 3x minus 1, right? So 3x minus 1 in brackets into height is 5x. Now this is what is equal to area, which is 60. So I'm equating it to 60. Fine, done. Next, what next I can do? I can just take this 2 to the other side. So when I take it, it becomes, right hand side will become 120, because 60 into 2 will give you 120. Okay, fine, yes. And what next I can do is, I will now write this as 5x into 3x minus 1. I can write it like this, right? Now one more step also I can do it here itself. This 5 is again like a common number only, right? So I can just take this 5 to the other side. So when I take this 5 to the other side, it goes there as what? It goes there as division. So 120 divided by 5. So left hand side I will be having x into 3x minus 1 is equal to, now right hand side will be 120 divided by 5, which will be 24. That's it. Okay, yes. Now I can multiply this two factors. So I will now get what I will be getting. I will be getting x into 3x minus 1, right? So I will be getting 3x square. 3x, x into 3x is 3x square. Then minus x. minus 24. Let me bring this 24 to the left hand side. This comes here as minus 24 is equal to 0. Now what next I can do? I've got a quadratic equation. I have to carefully factorize and solve this equation to get the value of x, right? So let's try to factorize this. I have my constant term as minus 24. So how can I break this minus 24? And see, oh, I'm sorry. So we need to divide, not minus 24. I'm really sorry. We need to divide because see here the coefficient is actually 3, correct? So I need to multiply this 3 into minus 24. So 3 into 24 will give you what? 3 into 24 will be 72, right? Yeah. So that means minus 72. So we need to break this minus 72, or we have to decompose, factorize this minus 72 into two numbers in such a way that the sum of those two numbers should be, see here I have minus 1x, it's like minus 1, correct? So minus 1. So in what way we can just break this 72? Very simple, right? When you recall the tables itself, you can easily understand. 8 9s are 72, very simple. So 8 9s are will give you 72, and at the same time I need a minus 1, so that means this is plus 8, this is minus 9. Simple, that's it. Okay, so now what I can do next is, I will take these two numbers here. Okay, fine. So I can now rewrite this as 3x square minus 9x plus 8x minus 24 is equal to 0. This way I can rewrite it. So that is how we broke that, right? So that's the reason I'm just writing like this. Now take the first two terms. I can take a 3x as a common factor. When I do that, I will be getting x minus 3 inside. Same way here I can take 8 as a common factor. Here also I will get x minus 3 inside. So it's equal to 0. Now what next I will have? I can now remove x minus 3 itself as a common factor. I will be getting what? X minus 3 into 3x plus 8 is equal to 0. Now what I can do is I can individually equate them to 0. Now when I equate it, I will be getting here, I will be getting x is equal to 3. This is what I will be getting. And now what about the other solution? Here I will be getting 3x plus 8 is equal to 0. Now when I equate it to 0, what will happen? I will be getting x is equal to minus 8 by 3, which will be a negative value. So that means I can reject this solution here itself. I will only take x is equal to 3. That's it. Okay, fine. Yes. Now the moment you take x is equal to 3, that's it. You can easily now tell what is the base and what is the height of your right angle triangle. Is it or not? Now tell me what will be the base. Now the base will be what? 3x minus 1. So 3x minus 1 will be, I'll just write it, 3x minus 1 will be, just take x is equal to 3 here. It will be 3 into 3 minus 1. So because x is equal to 3, right? That's what you have taken. I'm just writing it here. So 3 into 3 minus 1 will be 8. Okay. And what about the height? Height will be 5x. So 5x will be nothing but 5 into 3, which will be 15. So that means we are now ready with this base, which is 8, and height is 15. That's all. Now I can very well use Pythagoras theorem to find the hypotenuse, because finally we need to calculate the length of the hypotenuse. That's the question, right? So hypotenuse will be what? So hypotenuse, I mean AC square will be basically what? 8 square plus 15 square. So this will be 64 plus 225, which will give you 200 and this is 9, this is 8. So 289, right? So if AC square is equal to 289, just recall the squares. If AC square is 289, what is 289? 289 is nothing but 17 square. So AC will be just 17. So that means, what about the hypotenuse? So hypotenuse of our triangle is 17 centimeter, because the units is in centimeter only. Answer also will be coming in centimeter only. So 17 centimeter is going to be the hypotenuse of our triangle. So 17 centimeter is going to be the answer for your question number 7. Next we have question number 8 with us. Here in this question we have, in the given figure, okay, so the figure for this question is here, I have drawn it here. In the given figure, ABC is an isosceles right angle triangle. So remember, this triangle ABC, what we see here, this is an isosceles right angle triangle. So we know what is isosceles, we know what is right angle. Okay, so this triangle contains both the properties, and DEFG is a rectangle. Now you can also see a rectangle here. DEFG is a rectangle. Okay, so you have a big triangle and inside that you see a rectangle. Okay, fine. And they have also given about the measures. Let's clearly note it. If AD equals to AE equals to 3 centimeter. So now look at the figure. So AD and AE, these two measures are going to be 3 centimeter and 3 centimeter. So let's note it. And next what we have, and dB equals to EC equals to 4 centimeter. So where is dB? So dB and EC, okay, now these two lengths are going to be 4 centimeter, 4 centimeter. Then what we need to find here, find the area of the shaded region. Now you see here the region, this portion of the region is shaded. Now we need to find the area of that shaded region. This is going to be the question. Okay, yes. Now before we answer this question, let's try to carefully examine the given picture, and also at the same time let's quickly see about a right angle isosceles triangle, okay, or isosceles right angle triangle. Okay, now see here, this is what is an isosceles right angle triangle. Now I have drawn a right angle triangle here, and also it is an isosceles triangle. Now we all know about a right angle triangle, or any triangle, you will have the sum of the three angles will be 180 degree. Now if I give 190 degree here, since this is right angled also, now if I give you one right angle here, now what happens, this becomes 90 degree. Now remaining I have another 90 degree. That 90 degree should be equally given to these two positions. Is it or not? Why? Because this is an isosceles triangle also. So for that reason, the other two angles should be equal. So divide that 90 into two equal parts, 45, 45 here. That's it. So that means now these two sides will become equal. Okay. So this height is x and this base what you see here is x. Obviously, now what will happen to the hypotenuse of this triangle? The hypotenuse will become x root 2. How is that x root 2? It's very simple. We can just use Pythagoras theorem itself to get the answer, okay? Because this hypotenuse square will be equal to x square plus x square, which will be 2x square, is it or not? So in that sense, if I want to find what is hypotenuse, I need to take the square root of 2x square, which is what is x root 2. So now we need to know about the three sides. So the two equal sides are x and x, in the sense the other side hypotenuse is going to be x root 2. So this property we should be knowing. Okay, yes. Now the next thing is coming back to this shaded area. Now look at this shaded area. The shaded area itself contains three regions. Is it or not? So we'll have a close look of those three regions. Okay. Yes, I'll redraw it quickly. So here you have a triangle. Okay, correct. At the top you have a triangle. This triangle is what is ADE. ADE. Okay, this top triangle is what I've drawn here. And then we also have two triangles at the bottom. Correct? Yes. So I'll draw the other two triangles like this. Here you have one triangle. Okay, yes. Okay, fine. And the other one is on the right hand side. So right hand side also, here you have another triangle. Okay, so that means obviously the shaded area will be nothing but the sum of these three areas. That's it. Very simple. Okay, understand? Yes. And point number 2 is, these are all three triangles only, right? Each of them are going to be a triangle only. And now let's just observe what about the measures of this triangle. Now start from the top triangle. Now what about this top triangle? Top triangle is going to be 3 and 3. This is what is already we have. And remember, in this question itself they gave that this is an isosceles right angle triangle. So if this entire triangle is an isosceles right angle triangle, then what can we tell about this small triangle that you see at the top? That is also an isosceles right angle triangle only. How? Why? Because this angle will be 90 degree. How this angle is 90 degree here? Same way this angle will be 90 degree, because the angle that you see between the two equal sides is 90 degree. Is it or not? Now let's use this property. Let's use this property. Okay, fine. Yes. Now let's use this property. Now when I come to see about these two sides, I can compare it with these two sides. So x is 3, here also x is 3. That means the third side will be what? It will be nothing but 3 root 2. Because x, the third side will be x root 2. That means 3, 3. Here this side will be 3 root 2. Okay, fine. Yes. Just for a safety reason, I'm just writing it here itself. Okay, fine. Now what next we have? What next we have is, we also need to know about these two sides, because these two bottom triangles are also there, right? So bottom triangles, I know that this is 4 and this is 4. Fine. Yes. Now clear. Now let's again have a close look. Here we have this top triangle. This is a 90 degree. This angle is 90 degree, and this is a right angled isosceles triangle, which means I can clearly tell these two angles are going to be 45 degree each. Okay. Yes. Now what shape do we have at the middle, bottom middle? This position we have a rectangle, and if it is a rectangle, it is very clear that these angles are going to be 90 degrees. Correct? All these four interior angles of that rectangle are going to be clearly right angles, 90 degrees. So that means this is also going to be 90 degree. Now here I have a straight line. If this portion is 45, this portion is 90, then what can we tell about this portion? This will be again 45 degrees, is it or not? Because 45 plus 90 plus 45 will only give you the entire 180 degree, because in a straight line the full angle will be always 180 degree. Correct? Yes or no? Yes. Now the same argument follows here. I can match this angle to be 45 degree. And also we know about this full right angle, this full triangle, this ABC triangle. ABC is a right angle isosceles triangle, which means this angle A is 90, which we already marked here, and also angle B and angle C are also 45 degrees. So this is 45 degree, this is 45 degree. Correct? Okay, yes, fine. Now all these are done. All these are done. Now very clearly, now we will plan to get the missing sides. Okay, yes, fine. Now listen very carefully what I am going to do. Now I am going to consider just one of these two bottom triangles. Now bottom triangle also I came to now know that they are going to be what? They are going to be again right angled isosceles triangle. Why? Because this is 45, 45, this will be definitely 90. Here also 45, 45, 90. Now I know that this one, which one? This side is going to be 4, which means what I can tell about these two equal sides, because once this is a right angle isosceles triangle and this 4 will act as the hypotenuse, that means these two are going to be like equal sides. I'll take it to be x and x. Now what I can tell about this x and x? These two are equal sides. If these two are x and x, then definitely this 4 will be equal to x root 2. Correct? Yes, so I can equate x is equal to, x root 2 equal to 4, which means what will I get for x? Now x will become 4 divided by root 2. That's it. Okay. Now these two sides will become 4 by root 2. 4 by root 2. This is what I will be getting. Okay, done. Everything is done. Now we will have okay, we just got everything, whatever things we want, we got everything. Now we have got different approaches in which we can solve this problem. One way is we'll see both the things. We'll just see some two approaches. We'll see them one by one. Okay, one approach is I will come to add these three triangles area. How I can add it? It's going to be very, very easy. First you take the top triangle. If I want to find the area, what I can do? I can very easily do half into. Now this triangle is a right angle isosceles triangle, right? So for which what I can do is I can just consider these two equal sides itself to be base and height. So that means I will be getting what? Half into 3 into 3. I can do this easily. Why? Because this is what is a triangle which I can compare with here. So how the two equal sides act as base and height, the same way here also for this triangle also these two equal sides will act as base and height. So that's why I'm just making my calculation as half into 3 into 3. Done? Yes. Now plus. Now what next I can do? I can now do, there are other two triangles and they both are equal triangles. Is it or not? The same triangle is what I have here. So the areas will also be same. Is it or not? Yes, the areas will be same. So now I can do, what I can do is I can simply do 2 into, because I'm just collectively finding the area of these two triangles. So 2 into, now I can take any one of these triangles, these two triangles. Okay, 2 into, now we'll calculate the area of the triangle, half into. Now what about the base and height of this triangle? It's again very simple. The base and height are going to be 4 by root 2 and 4 by root 2. So 4 by root 2 into 4 by root 2. That's all. Very simple. Now once I calculate this, I can easily get the answer. Let's do this calculation very carefully. Now once I do this one, I will be getting what? Half into 3 into 3, which will be 9 by 2, right? So 9 by 2 will be 4.5 plus. Now come to this part. Here collectively we are finding the area of both the triangles. Okay, so that's why I put the 2 into. Okay, so 2 into half into this calculation. So anyways I can cancel this 2 and 2, and now I will be having 4 4s are 16 by root 2 into root 2. What about root 2 into root 2? It will give you 2. So 16 by 2, this becomes 8. So finally I will have 4.5 plus 8, which will give me 12.5 centimeters square. Fine. Okay, yes. Now this is one way to get my answer. Okay, this is one way to get my answer, and the other approach to get the same answer will be, let me give you another approach also to solve the same problem. It's going to be very easy only, not a very difficult one, very easy only. Now if at all I want to find the area of the shaded region, I can also think in a different way. How I can think is, just take the full triangle ABC, just take the triangle ABC, you calculate the area of this full triangle ABC. From that you just subtract the area of this rectangle. this rectangle DEFG. So I can do this calculation also to get the answer, right? So let's quickly do this. This also can be done, right? Very simple. Now how can I find the area of this triangle ABC? Very simple, very simple. Why? Because now to find ABC, now just look at this entire side. This entire side will be 3 plus 4, 7. Same way here also. 3 plus 4, 7. So AB is 7, AC is 7. Now our triangle ABC is going to be a what? It's a right angled isosceles triangle. So which means I can take these two equal sides to be base and height. So I will be getting half into 7 into 7. I hope you understood that, right? Half into base into height. I'm just taking the equal sides to be base and height because they are perpendicular. That's why, right? So half into 7 minus. Now come to the area of this rectangle. What about the area of this rectangle? I can easily find the area of the rectangle. How? Means here already I found the length and breadth of the rectangle, because this 3 root 2 what we already found is going to be the length of our rectangle, right? So 3 root 2, I am putting it here. And what about the breadth of our rectangle? This height side of this bottom triangle will act it will what act as the breadth of our rectangle. So 4 by root 2, breadth of rectangle is 4 by root 2. Now I can now tell the length is 3 root 2 and breadth is 4 by root 2. Now to find the area of the rectangle, what should be done? We have to multiply length into breadth. So 3 root 2 multiplied by 4 by root 2. This can be done to get the answer. Is it or not? So now once I do this, let me see what answer I will be getting. Now half into 7 into 7. What is 7 sevens are? It will be 49. So 49 by 2 will be 24.5. 24.5 minus. Now this side rectangle's area will be 3 root 2 into 4 by root 2. I can cut this root 2 and root 2. I will be having 3 into 4, which will be 12. Now just do the subtraction. 12.5 minus 24.5 minus 12. This gives you again 12.5 centimeter square. That will be the right answer. Okay, fine. Yes. So one single problem only, but we have got two different approaches in which we can solve it. Okay. Always go for this kind of method. That will be what is time efficient. You can easily solve that problem. It won't take more time, but you see that you are clear with the other concepts. Okay, fine. Yes. Whatever values which are missing, you just quickly see that you are finding those missing values first, then you try to find out the answer. Okay, fine. Yes. Now please remember something, like whenever you need to find the area of the shaded region, you just take it like from which area, if you subtract which area, you will be able to get the answer. That way, if you think, means that will be very efficient, it will be easy for you to solve the problem. That's why. Okay. So yeah, however, the answer to this question is 12.5 centimeter square is going to be the answer for your question number 8. Next we have question number 9. The diagram given shows two parts drawn inside a rectangular field 50-meter long and 35-meter wide. So you can see a rectangle shaped park here, and it is given that the length is 50 meter and breadth is 35 meter. And inside this rectangular field, what happens is they are made two parts. Okay, so one is along the length they have drawn they made a pathway like this, and the other one is along the breadth they made another pathway. Okay, fine. So this way there are two parts are made. Okay, it is running along like through the center, okay, through the middle portion or somewhere like this. So there are two parts like this. One is a horizontal one, the other one is a vertical one, and the width of each path is 5 meter. So the width means this breadth, they are talking about this width, that's what they are mentioning it. Okay, this portion, this length is going to be like 5 meters. That is what is given. Okay, so this is 5 meters, and at the same time this is also 5 meters. That we have to understand. Okay, now what is the question? Find the area of the shaded portion. That is, we need to find the area of the pathway. That's all. This is the question. It's very simple. Okay, yes. Now let us not complicate this problem. Very simple. So only thing we need to know is finding the area of a rectangle. We know that clearly, right? Find the area of a rectangle. How do you find it? Length into breadth. That's the only thing we need to know here to solve this problem. Apart from that, we can very easily solve this problem. See what I'm going to do now. Okay, yes. Now first what I'm going to do is I'm going to consider this full rectangle. The full rectangle. Okay, yes. I mean the full rectangle. So the full rectangle, the full portion. What about the full portion area? Full portion area, if I want to find, I need to try to find the area of this bigger rectangle. That's all, right? So bigger rectangle is going to be very simple. Length is 50 into breadth is 35. So this will give you 50 into 35, 5 and then 17. So 1750 meter square. This will be the area of the I mean the full rectangular field. This is going to be the area, but this is not our question. Our question is to find the area of this pathway. Now listen very carefully what I am going to do. I am simply going to take these four unshaded portions. There are four unshaded portions here, is it or not? Now what about those four unshaded portions? They are again going to be rectangles. There are four rectangles here, is it or not? Now I am going to take these four rectangles as A, B, C and D. I hope you understand this. Okay, yes. Now this is A, B, C and D. Now what if I just merge that A, B, C and D? Now what happens if I merge A, B, C and D? If I put it one next to other, this is how it will look, is it or not? So just imagine this figure, this is how it looks. So A here, B here, C here, D here. So ignoring that pathway which is there in between, if I try to just make it closer, this is how that A, B, C, D, when they are put near, this is how it looks. Now once again, this will be forming another triangle, another rectangle, is it or not? So this will form another rectangle. And can you please tell what will be the length and breadth of this rectangle? Any idea? So we are clear about the construction, but what about the length and breadth of this rectangle? It's very simple to say. For our bigger rectangle, the length is 50. Now this pathways portion alone is removed off. So that means what will be the length of this remaining rectangle? It will be 50 minus this one, this 5, that will be 45. Is it or not? It will be 45 meters. Same way, now what about the breadth of this rectangle? This breadth actually comes from this 35 from which I am removing this pathways width, which means 35 minus the 5. 35 minus 5 will give you 30. So that means this will give you 30 meters. I hope I understand this. Is it or not? So I'll remind you, this 45 is actually 50 minus 5 and this 30 is actually what? 35 minus 5. That's it. Okay, that's how these two values come. Okay, yes. Now what I'm going to do is I'm going to find the area of this small rectangle. Okay, so the small rectangle area, I'll write it in short, is the area is going to be what? Here we have length into breadth. So 45 into 30. So 45 into 30 will give you how much? Again 0. 3 5s are 15, 1 carry, 12, 13. So 1350 meters square. This is going to be the area of the small, I mean this rectangle what we formed. Now I got to know the bigger rectangles area and the newly formed smaller rectangles area. So these two are done. Now how can I find the area of the shaded portion? Now very simple, area of the shaded portion will be nothing but this full area minus this small rectangle area. Now once I do this, I can easily get the answer, is it or not? Because from the full area, I remove these four rectangles area. That four rectangles area is what? Together we got it to be 1350. If I remove it, I will be left with only this pathway, the shaded region. That's what I'm planning here. Okay, so now my answer will be 1750 minus 1350, which will be exactly 400. So 400 meters square will be the answer to your question number 9. That's it. Next we have question number 10 with us. Here we have a footpath of uniform width runs all around the inside of a rectangular field which is 50 meter long and 38 meter wide. So they say that there is a rectangular field here, and also it is given that there is a there is a length and breadth. Okay, so for the rectangle we will be having length and breadth, right? So here the length is going to be 50 meters. So here I have drawn a rectangle. So this is 50 meter length and 38 meter wide. So breadth is 38 meters. We'll note it here. Fine. Yes. If the area of the path is 492 meters square, now there's a pathway inside that rectangle. Okay, and how is that pathway? It is going to be around the inside of the rectangular field. So that means it will be like this. It will be running around the rectangular field. So this full rectangle, the bigger rectangle is what you see is going to be the rectangular field, and the shaded portion what we see there, no, that is going to be the pathway. Okay, yes. And also it is given that the pathway is going to be of uniform width. Uniform width means this width is going to be constant, uniform. Okay, now let us do something. We'll take this uniform width to be x meters. I'll take it to be x meters. Okay, fine. Now they gave that area of the pathway is what is 492 meters square. This is what is given. Now if that is so, then find the width. That means we need to find the value of this x only. So let's see how we can find the value of this x. Okay, yes. Now again, let's be clear with the properties of rectangle. Area of the rectangle is going to be what? Length into breadth. That's it, right? Yes. Now look at this pathway. In order to find the area of this pathway, can you please plan what we have to do here? It's going to be very simple. From the bigger rectangle area, if I subtract the smaller rectangle, the unshaded region, you see there inside, right? There's a smaller rectangle inside. If I minus the smaller rectangle's area, I will be able to get the area of the pathway, right? Yes. So let's note it here. So area of the pathway will be the bigger rectangle area minus smaller rectangle area. So when I do this, this will be what will give you, it will be giving you the pathways area, okay, the area of the pathway. Now keeping this in mind, we'll just form an equation, and from there we will solve and get the answer to this question. Now again, listen to this question very carefully. Now area of the bigger rectangle is very easy for us to find. The length is 50, breadth is 38, so I can simply do 50 into 38. So yes, this is done. Okay, now minus, now come to the smaller rectangle. Here is where we need to be very careful. Now smaller rectangle's area, if we need to find, we need to concentrate on the length of the smaller rectangle. What will be the length of the smaller rectangle? See, from this extent to this extent, this extreme, this is going to be the length of the bigger rectangle, which is 50. But what about the smaller rectangle? It's going to be, see here, this border to this border is what is the smaller rectangle's length. Now, out of this entire 50, I need to remove a x here and x there. That means I will be left with what? I will be left with this measure. I will be left with what? This will be nothing but this total 50 minus x, which means it will be 50 minus 2x in meters. I hope you understand this. So I repeat. So what I simply did is, from this 50, I'm just subtracting x here, both the sides. So that gives you the length of this smaller rectangle. Same way, to find the breadth of the smaller rectangle, what can be done? This is going to be the breadth. Same way, breadth of the bigger rectangle is 38. Now from 38, I need to minus this x, because along the breadth also you have x and x, is it or not? So that means this will be 38 minus 2x. Now area of the smaller rectangle will be nothing but this length, which is 50 minus 2x into the breadth 38 minus 2x. Now this will be what equal to the area of the pathway, which is given there in the question itself to be 492 meters square. So I am equating this to 492. Now let's carefully solve this equation. Now once we solve this itself, we can get the value of x, and that will give you the what is the width of that pathway. That's it. Okay, so let's try to carefully solve this. So this will be 50 into 38. Don't multiply this, don't multiply, minus. Now let's carefully calculate this product. Okay, now what happens to this product? This product will be nothing but 50 into 38, right? So 50 into 38, so minus of 50 into 38. Then next, what we will have? Next we will have 50 into this 2x, minus 2x, and this 2x into 38. So what happens to this product? Let's make it very careful. Again, I repeat it, I'll tell it again. So 50 into 2x minus 2x and minus 2x into 38. So this will give you minus 100x, and this will give you minus minus 2 into 38. Is it or not? So that will be like 76. Is it or not? So which means I will be altogether getting what? I will be getting minus 176x. But already we have a minus in here outside, so this becomes plus 176x. I hope you understand this, right? Yeah, okay, fine, yes. And next we have to do is, we need to multiply these two values also, right? So here also we have values. So here what happens is, like, we will be having minus 2x into minus 2x will give you plus 4x square, but I have a minus outside, so this will become minus 4x square. This is equal to 492. Let's again clearly check this. So 50 into 38, it's already there. And here 100x, here 76x, so 176x. So minus and minus, this becomes plus, and 4x square, which is in minus. That's it. Okay, now I can clearly cancel these two values because they are the same. 50 into 38 minus 50 into 38, I can cancel this. Now I will be having this expression alone. Let us take these two expressions to the right hand side. Now what if I bring this to the right hand side? What happens? I will be having 4x square minus 176x plus 492 will become equal to 0. That's it, because there will be nothing here on this side. Everything went there. So this is what I will be having. Now next what I can do now is I can just divide this full equation, this entire equation by 4. Now when I divide it by 4, I will be getting what? 4x square by 4 will be x square minus 176 by 4 will give you 176 by 4 will give you 4 4s are 16, balance 1, again 4 4s are 16. So 44x minus 44x again plus, here I have 492. This also to be divided by 4. So I will be having 4 1s are 4, and here I have 9. 4 2s are 8, balance 1. So carry 1. So it will be like 4 3s are 12. So that's it. So this will be equal to, right hand side 0 by 4 is going to be 0 only. Okay, now clearly we got a quadratic equation. Now I can factorize this equation and then get the answer, right? Okay, yes. Now listen very carefully, listen very carefully. Now I have to factorize this 123. So 123 we will factorize it in such a way that I need to get a pair. And how should be that pair? The pair should be in such a way that the product should be 123 plus 123, but the addition sum should be minus 44. That way we have to factorize it. Listen carefully. How I can factorize? I cannot do this in one tables, 1 into 123. No, this pair won't work. Next I can go for, I cannot go for 2 tables. 123 cannot be divided by 2. I can go for 3 tables. So 3 tables, this will be 41 times. So 3 into 41 will give you 123. And fortunately, what happens? If I include a minus, I got a proper pair. So that means I will be having x minus 3 into x minus 41 will be equal to 0. So I am getting 2 factors. Now from this I will get 2 possible values for x. X is equal to 3 and x is equal to 41. So I am getting 2 values for x. But please hold on, please hold on. Both of them are the values of x only. And x is basically what? The width of the pathway. That is what is x. Is it or not? Although we got both the values to be positive, we'll have to also think about which one will fit the question's situation. That we have to carefully think. Okay. Now what if x is equal to 3? There's nothing wrong. Because if x is 3 means this length will become what? 50 minus 2x. That is 50 minus 6, because I just take x as 3 here. Okay. You don't have to calculate it separately. You can do it in mind itself. 50 into 2 into 3, which means 50 minus 6 will become 44. And that side, what happens to breadth? Breadth will become 38 minus same 6. 38 minus 6 will become 32. So I have no problem when I take x as 3. Now you take the other value, x is equal to 41. When I take x is equal to 41 and put it here, you know what will happen? 50 minus 2 into 41. So 50 minus 82. And that will give you a negative number. Is it or not? So I don't have any problem with this 50 or 38. That is clear. But when I take the value x is equal to 41 and try to substitute it here for that inner rectangle, then I am facing a problem. I am getting the length and breadth to be negative numbers, which is not permissible. So I cannot possibly have x is equal to 41 to be a breadth for this, I mean the width for this pathway. Okay. So that means the correct answer is x is equal to 3. So 3 means, I mean like along with the units, if I want to write meter, 3 meters. So x is equal to 3 meters is going to be the correct and suitable answer for your question number 10. Now we have question number 11 with us. A wire, when bent in the form of an equilateral triangle, encloses an area of 36 root 3 centimeters square. So there is a wire. You are just making it as you're just making it in the form of an equilateral triangle. So see here, this is an equilateral triangle. You are bending it like a form of an equilateral triangle. You are forming an equilateral triangle, and the area is 36 root 3 centimeters square they gave. Okay, yes. So let's note it. Now area is 36 root 3 centimeters square. Fine, we have noted it. Now find the area enclosed by the same wire when bent in the form of a square and a rectangle. So we have got two subdivisions. We need to solve both these things. Now one thing we need to understand, there is a wire with some fixed length. So that means what we need to understand is the length of the wire is going to be fixed. Now that fixed length is what is going to transform into different shapes. First time it is going to take an equilateral triangle shape. Here square shape and here rectangle shape. Same length only. So that means what we can clearly understand it from here is, we can understand that the perimeters of these shapes are going to be all equal. Is it or not? Because you are going to take the same length only, you are going to form the shapes, which means the perimeters are going to be same. Okay, the perimeters the perimeters for all the shapes are going to be same only. So the strong point we have to understand it here. Okay, yes, so this is the way we need to understand everything in an application way. So yeah, that way they have formed the question. Okay, yes, now coming back here, we need to find the area of this square and area of this rectangle. So first of all, we'll start with the equilateral triangle itself. Now what we know about this triangle is area is 36 root 3 centimeters square. This is what is we are given in the question. Now what about the area of an equilateral triangle? Area, we already came across the formula, right? So area is going to be what? Area is going to be what? It's going to be root 3 by 4a square. Okay, so root 3 by 4a square is going to be the formula to calculate the area. So this is what is equal to this 36 root 3. So now when I solve this, I can easily get the value of a. Okay, yes, or otherwise here we have taken the sides of the equilateral triangle to be s. So better I will use the same notation, not a, I'll use s. So root 3 by 4 s square is going to be equal to 36 root 3, where this s is going to be there each side of this equilateral triangle. Now let's solve this. I will first of all cut this root 3 and root 3 on both the sides. Now I will have s square is equal to 36 into 4. Now I will have s is equal to, very simple, I have to take square roots, because s square I have taken a square root. Right hand side, if you take square root of 36 will be 6 into square root of 4 will be 2. So 6 2s are 12 centimeter. So side is going to be 12 centimeter is going to be the side of our equilateral triangle. So this is done. So side is done. That means what will be the perimeter? Perimeter will be what? See, each side is 12. So that means this is 12, here 12, here 12. So the perimeter of this equilateral triangle is going to be 12 threes are, it's going to be 36 centimeter. So this is the first point we are catching from this one. Okay, yes. Now the moment we catch this, the perimeter is 36 centimeter, we can understand that the length of the wire is 36 centimeter. That's it. This is a key idea. Okay, now what next? Now the same 36 centimeter length is what is going to transform into a first subdivision square. Let's see what happens when you make this as a square. Now we are forming a shape of a square. That means the perimeter of this square is going to be what? 36 centimeter. Okay. Now what about the perimeter of a square whose side is A? Very simple. A. 4 A's are there. So 4A is going to be the perimeter. So I can very well equate 4A equals to this 36. So when I equate this, I will be getting A is equal to 9 centimeters. So each side of this square is going to be 9 centimeters. So 9. That's it. But what is our question? Our question is to find the area. To find the area, right? So area of the square is going to be what? Area will be equal to, I'll just take this space itself. Area will be equal to what? Area of a square is side into side. So 9 into 9, which will give you 81 centimeter square. So area of the square is 81 centimeter square. And now next is a rectangle. We have a rectangle, and there's a condition also, a rectangle whose length is 2 centimeter more than its width. So here L is the length, B is the width. I am taking the rectangle this way, length and breadth. And what is that the condition they gave here? Length is, that is, this L should be 2 centimeter more than the width. Okay, that means width is B, so B plus 2. So L is equal to B plus 2. That's what they come to tell. So this is the condition, and based on this condition we have to form the rectangle. Now again the thing is what? Again for this rectangle also the perimeter is going to be the same 36 centimeter only. Okay, yeah, let's use this here now. Now what about the perimeter of a rectangle? Perimeter of a rectangle means again you need to add all the four sides, like how we added for the square, A plus A plus A plus A, 4A. The same way here, if you add L plus B plus L plus B, you will be getting what? You will be getting 2 times of L plus B, and that's what is equal to 36. Okay, yes, yeah, that means we will have what? L plus B is equal to 36 by 2, which will be 18. And now I can use this condition here. I already know L is equal to B plus 2, right? So here in the place of L, I will substitute B plus 2 plus B is equal to 18. So when I solve this, I will be getting what? I will be getting, let me continue it here, right hand side. So I will be getting 2B plus 2 is equal to 18, which means I will be getting 2B is equal to 18 minus 2, which will be 16, and B is equal to what? I will be getting B is equal to 8. Okay, so that means breadth of this rectangle is 8 centimeter. And what about the length? So if breadth is 8 means length is equal to B plus 2. That's it. So 8 plus 2 will be 10. So breadth is going to be 8 centimeter, length is going to be 10 centimeter. That's it, very simple. Now again I need to find the area of this rectangle, right? So area of the rectangle is going to be length into breadth, right? So it will give you 10 into 8, which will be 80. So 80 along with the unit centimeter square. So this is going to be the area of the rectangle. So finally we got the areas of both the square and also the rectangle. So square area will be 81 centimeter square, and second subdivision area of the rectangle's area is going to be 80 centimeter square. So these are going to be the answers for your question number 11. Now next we have question number 12 with us. Here the area of a trapezium is 540 centimeter square. So there's a trapezium, and for which the area is given 540 centimeter square. So let's note it, okay? So area is 540 centimeter square. Then next what else we have is, if the ratio of the parallel sides is 7:5. So the two parallel sides is going to be the ratio they are given, okay? So they are going to be 7:5. Now look at this picture. I have drawn a trapezium here. So you know about the basic properties of a trapezium. A trapezium is going to be a quadrilateral only, okay? You have four sides, but out of the four sides, two of the opposite sides will be parallel and the other two sides not necessarily parallel, okay? So such a quadrilateral is what you call it to be a trapezium. And look at this very carefully. In order to find the area of the trapezium, what we do is, we have got the two parallel sides, right? Let us just take them to be A and then B. Note it very carefully. The two parallel sides are going to be A and B, and the distance between them, or the perpendicular distance between those two parallel lines, that we will take it to be H. Okay, fine. Yes. Then the area will be, okay, note that this is a perpendicular distance. Okay, yes. Now area will be given by half into this height H into A plus B. That is the sum of the two parallel sides. So this is how we find the area. This is a formula to calculate the area of a trapezium. Now coming back to this question. Now what is given here? The ratio of the two parallel sides is 7:5, which means this ratio A is to B. This ratio is what they gave here. Okay, A is to B is what is 7:5. And also the distance between them is 18 centimeter. So what about the distance between them? H. So H is equal to 18 centimeter. So all these things are given. Now what is that we need to find here? Now we need to find the length of the parallel sides. That's it, very simple. That means we need to find the values of A and B. Simple, okay? Yes. Now since we have the ratio, let me take A as 7x and B as 5x. Because the ratio is 7:5, right? So A is 7x, B is 5x. Now let's directly use the area formula. So area formula, according to area formula, what we have? Half into height H. H is 18 for us. 18 into, now what about inside? We have A plus B. A plus B will be what? 7x plus 5x, which will be 12x. So 12x will be equal to, now what's the area? Area is 540. So we'll equate it to 540. Now we will do this calculation. So now when I try to cut it, I will be getting 12 9s are 18, and we have 9 and 12x. 9 and 12x is equal to 540. This is what we have it, right? Either we can multiply it here itself. Okay, let us multiply it here itself. Okay, so 9 18 9 12s are 108. 108x is equal to 540. So which means I will have x is equal to 540 by 108. So 540 by 108 will be exactly what? It's easy to divide. Just by looking itself we can tell, right? 1 5s are 5, 8 5s are 40, which means it's exactly 5. So x is equal to 5. This is what we are getting. Now the moment x is equal to 5, we can now easily tell the values of A and also B. So A will be what? 7x. So 7 5s are 35 centimeter, and B is 5x. So 5 5s are 25 centimeters. So these are going to be the values of A and B. So the answer is going to be A 35 centimeter, B 25 centimeter. These are the lengths of the two parallel sides, and this is going to be the answer for your question number 12. Question number 13 with us. A sheet is 11 centimeter long and 2 centimeter wide. So it is very clear that the sheet is of a rectangle shape, right? So here I have drawn the sheet, and this is going to be the length. So length is given to be 11 centimeters. So we'll note it, 11 centimeter, and breadth is 2 centimeters. So we will note it. So this is going to be the length and breadth of the rectangular sheet. Circular pieces 0.5 centimeter in diameter are cut from it to prepare discs. So now what they come to tell is, they take this sheet and they're going to cut out circles, circle formed shapes, circle forms. They are going to shapes, just going to take it out. Okay, they are going to remove it out to prepare discs. So that's what they are going to do, and they are given the diameter of each of those circles is going to be 0.5 centimeter. Now look at here, this is going to be the small circle shape, and the diameter of this circle is going to be what? It's going to be 0.5 centimeters. So you know what is diameter of a circle? Diameter means the width of this circle, okay, end to end. So from one extreme to the other extreme, that length is what you call it to be diameter. Now this is what is going to be 0.5 centimeter. Okay, yes. Now here we need to understand something. Now when I cut out a circle from here, so what is the meaning of this? This circle will take the space of, or it can be enclosed by a square whose side will be same as the diameter of the circle. Is it or not? So that means I can enclose this circle with a square. Okay, fine. And that too, in what way I can enclose? I can enclose it in such a way that that square whose side will be what? It will be same as the diameter of the circle, which means the square's side will also be 0.5 centimeter. That's all. This is a simple idea. So that means if I want to cut out a circle of this side, it is like I am going to occupy, or I am going to take this much area, a square's area whose side will be 0.5 centimeter. Now finally, what's the question? Calculate the number of discs that can be prepared. This is going to be the question. Now I want to find the number of the circular discs that I can prepare from this sheet. This is the question. Now just how we saw this. If I want to remove the circle, cut out a circle, it means I'll have to consider the square's region area. Is it or not? Fine, yes. So that means it is like this much portion of the area will be removed out from that sheet. Is the point is clear? Is the point clear to you? Why? Because if I cut a circle out of this, I will have to remove this area. And then if I want to cut my next circle, now what happens? I cannot use the other remaining portion of the square. I will not be able to use it. Next, I have to go for the next circle only like this. The next circle will be only like this. And the point to be noted is, again the next circle will take the area of the square whose side will be the diameter of the circle. Okay. And so on. This is how it goes. So now if it goes like this, it is like the number of discs we are calculating, right? It is like equal to how many squares of the side 0.5 centimeter are there inside this rectangular sheet. This is a simple idea. So now I can very simply do my calculation. In order to find the number of discs, what I can do is, I will first of all take the area of the rectangle, okay, area of the full rectangle, okay. So area of the rectangle, and out of this full rectangle, now what I'm going to do, I'm going to divide this entire area only into small square pieces, which means I can divide this by area of each square, area of the each small square, okay, square. Now when I do this, this will automatically give me the total number of circular discs, how many are formed. That's it, okay, yes. Now we know how to find both the things. Area of a rectangle is going to be what? Length into breadth, is it or not? So length into breadth will be 11 into 2. Be careful with the units, okay? 11 centimeter and 2 centimeter. So we are doing our calculation in terms of centimeter itself. So 11 into 2 divided by, now what about the area of a square? Area of the square is going to be side into side. Now listen here, side is going to be 0.5 centimeter, right? So that means 0.5 into 0.5. So this calculation will give you the answer for this question. So this you can easily do it. So what will be the answer for this? Of course, this is going to be what? 11 into 2 divided by, this is like what? 1 by 2 into 1 by 2. Is it or not? Yes. Yeah. Now I can simply do what? 11 into 2 into, I can bring this 1 by 2 to the numerator so that they will go there as reciprocal. So into 2, they will go like this. Now this calculation will give you the answer. So this will give you what? 11 into 2 into 2 into 2. So 2 into 2 into 2 will be 8. 11 8s are 88. So totally 88 discs can be formed using this rectangular sheet. So answer is 88 is going to be the answer for your question number 13. Moving next to question number 14. A road 3.5 meter wide surrounds a circular plot whose circumference is 44 meter. Now let's see the construction. So there is basically a circle. You can see this circle, and covering that circle, okay, around that circle there is a circular shape road is also there with uniform width. And what is the width of that pathway, the road? It is given to be 3.5 meter. Okay, that means this uniform width is going to be 3.5. So let's note it. So this width is 3.5 meter. Okay, I'm noting it here. Fine. Yes. Now if you look at it closely, here in this figure you can see two circles. One is the inner circle and the other one is the outer circle. Fine. Yes. And the gap or the region that you can see in between these two circles is what is the roadway. That's it. Okay. Yes. Now let's continue the question. Then find the cost of paving the road at rupees 50 per meter square. So now we need to find the cost to prepare or make this road at a rate of rupees 50 per meter square. So basically we need to find what? We need to first of all find the area of this road pathway, then we have to find the cost. So this is going to be the procedure. And now again come back to the observation of this given figure. As I told, we have got two circles here, right? One is the inner circle. Now just see about the inner circle. Inner circle. Now inner circle, what about the radius of that? We don't have the radius. But you see here, it is given that it surrounds a circular plot whose circumference is 44 meter. That means about this inner circle, we are given the circumference. So circumference of the inner circle is 44 meter. This is given. Okay. Yes. Fine. Now let me do something. Let me take the radius of the inner circle as small r. Let it be small r. Okay. Yes. Fine. And now once you fix the radius of the inner circle to be small r, now connect it with this inner circle circumference is 44 meter. This is what is given here, right? So let's go back to the circumference of the circle formula. What's the circumference of the circle? We know circumference is 2 pi into radius. So radius, as per our assumption, it is going to be r. So 2 pi r is what is equal to 44 meter. Okay. So I'm equating to 44. Let's first solve and find out the value of r. So 2 into pi, we will take it to be 22 by 7 into r is equal to 44. So now when I try to solve this, what I will get? I will anyways get 2 22s are 44. I can exactly cancel with this right hand side 44. That's it. So I will be simply left with r is equal to 7 meter. Okay. Now successfully we got the value of this small r. Okay. So that means this is going to be 7 meters. I mean the radius of the inner circle is going to be 7 meters. Okay. It's fine. So inner circle radius is, we are now ready with it, 7 meter. That we got it. Fine. Okay. But that is not our question. Our question is to find the cost to prepare the road. That means we should concentrate in finding the area of the roadway. Now just now I told you area is what here actually. Area is going to be the path or the region that we can see in between these two circles. That means the outer circle and the inner circle. Now to find the area, we need the radius of the outer circle also. Correct? That means I'll put it like this. Outer circle, we'll just see what will be the radius of the outer circle. Inner circle radius is ready, 7 meter. But outer circle radius we want to find, right? So how can you find it? Very simple. See, outer circle radius is again from the same center point. You need to find the distance to the outer circle's extension. Okay, this distance is what will be the radius of the outer circle. Now what will be that distance? Very simple. Already out of this full distance, this part will come inside inner circle itself. So this will be a 7. Okay. And what about the other part? That will be 3.5. Correct? That means radius of the outer circle will be nothing but 7 plus 3.5, which will be 10.5 meters. Is the idea now clear? So now we are clear with both the radii values. Outer circle radius, inner circle radius, both are ready. Now we will just try to see what will be the answer to the question. Okay, yes, fine. Now the question is asking for what? Cost. So how can I get the cost? Cost will be equal to, we'll try to directly put it. Okay, fine, yes. So cost will be equal to, first of all, area of the road. Okay, area of the road multiplied by, what about the cost per meter square? Because area of the road we will be getting in terms of meter square only, and that should be multiplied with, for each meter square the cost is going to be 50 rupees. So multiplied by 50. Once we do this calculation, we will get the final answer. Is it or not? So yeah, coming back. Now what about the area of the road? Area of the road can be found by what? We can just do it by the calculation of outer circle area minus inner circle area. That's it. Okay, yes. So now what about the outer circle area? Area of the circle is going to be what? We know the area of the circle formula, right? So area of the circle is, if you want, I'll write it here. Area of the circle is going to be pi r square, where r is the radius. Now here we need to find the area of the road. So outer circle's area, first we have to find. Outer circle area will be, it will be what? Pi r square, right? So 22 by 7 into what about the radius of the outer circle? It will be 10.5. So 10.5 square minus, now coming to the area of the inner circle. Area of the inner circle will be again pi r square. So 22 by 7 into, this time what about the radius of the inner square? That will be 7, right? So 7 square. Now this entire thing multiplied by 50 will give you the answer. Okay, yes. Now listen very carefully what next I am going to do. Next what I am going to do is I am going to write this as 22 by 7. I am just taking 22 by 7 as a common factor outside. Now once I do that, what I will be having inside, just look at it carefully. Inside I will be having 10.5 square minus 7 square. Is it or not? That's what I will be having, right? So listen very carefully. I repeat. Once I take 22 by 7 outside, I will have 10.5 square minus 7 square. Now the 10.5 square minus 7 square can be written as a square minus b square form. That means that can be expanded as what? A plus b into a minus b. Is it or not? Fine. That way we can write it, right? So we can write as a plus b into a minus b. So once I do that, I will be having what? I will be having multiplied by, now calculate what is a plus b. Just do it in your mind itself. 10.5 plus 7, which will be 17.5, multiplied by next 10.5 minus 7, which will be 3.5. That's it, right? Made it very simple. So I hope you understood this. First step, what I did is 22 by 7, I took it as a common factor outside. Now I will be left with 10.5 square minus 7 square. That 10.5 square minus 7 square is what I am expanding like this, using a plus b into a minus b. Okay, a plus b is 17.5, a minus b is 3.5. That's it, very simple. Multiplied by 50. Now all we need to do is just get this product. If you want, you can simplify anywhere. So first I will cut this 7 and 17.5. It will be exactly how many times? It will be 2.5 times, correct? Yeah, it will be 2.5 times. Next what I will try to do is 22 into, okay, let me change the decimals. Okay, 2.5, let me write it as 5 by 2 into 3.5 is nothing but 7 by 2 multiplied by 50. That's it. Okay, just I'm removing all the decimals. That's the only thing here. Now again I can cut the numbers. So this one, okay, so 2 and 22, this will be 11 times, and again this one 2 and 50 will be 25 times. So now I will have 11 into 5 into 7 into 25. This is what I will be having. So this would give you how much? First of all, we'll do 5 sevens are 35. 35 into 25 will be giving you what? So 35 into 25 will give you 5 5s are 25, and again 3 5s are 15, 2 5s are 10. So I will have 15 plus 10 to be 25, plus 2 will be 27. So I will have 2 carry. Again I will have 3 2s are 6, plus 2 will be 8. So I will have 11 into 875. Now one last step we need to do. We have to multiply these numbers. So 11 into anything, that can be easily done. So let me do it easily. So 11 into 875, that's all right. So first I will put the units place 5 here. So 5 plus 7 will be 12. So 2, 1 carry here. 7 plus 8 will be 15, plus 1 is 16. Again 1 carry with 8. 8 plus 1 will be 9. So rupees 9,625 is going to be the answer for your question number 14. So I think this procedure is clear to you. So here we have a clear structure given in the question. So what we do here is basically we are first of all making the structure inner circle, outer circle. Then we try to find the radius values. Then from there we try to find the area of the pathway, the road. How we find it? Just very simply we are doing it like area of the outer square minus area of the inner square, and then we are multiplying with the cost per unit. So once I do that, I get the complete answer. So 9625 rupees is going to be the answer for your question number 14. Now question number 15. A copper wire, when bent in the form of a square, encloses an area of 121 centimeters square. So here is a square here, and there is a copper wire. This wire is what is bent in the form of a square, and they gave the area of the square is going to be equal to 121 centimeter square. I'm noting it here itself. Okay, yes. Now next is, if the same wire is bent into a form of a circle, then find the area of the circle. So we need to find the area of the circle now. Okay, now the same wire is taken. Now with that wire, what they are going to do is they are going to just make a circle now. Okay, now that circle's area will be how much? So they form a square first. Square's area they give 121 centimeter square. Now if the same wire is made into a circle, means that time what will be the area of this circle? That's my question. Okay, yes, fine. Okay, coming here, now we'll start from the area of the square itself. We know what is the area of a square. Area of the square is going to be a square, is it or not? So a into a square is what is going to be equal to this 121, where a is going to be the each side of the circle. Now a square is 121, means very easy. A will be what? Square root of 121, which is 11 centimeters. So each side of the square is going to be 11 centimeter. That's it. Now this side we got. Now what will be the perimeter of that square? Perimeter will be a plus a plus a plus a, because the four sides we have to add it up, right? So 4a. So 4a will be what? So 4 times of 11. This is equal to 44 centimeter. Yes, fine. That's it. Now why we are finding the perimeter of the square? Why? Because this 44 centimeter is what is spanning as a circle, square, and also as a circle, is it or not? So that means the meaning is what? The perimeter of the square is what is same as the circumference of the circle. That's what we have to understand. So that means for the circle also, the circumference is going to be what? Same, 44 centimeter. Okay, now let's note this. So circumference is 44 centimeter. 44 centimeter. Okay, yes. But this is not our question. Our question is to find the area of the circle. Very simple. We know what is circumference. Circumference of the circle is what? 2 pi r, is it or not? So 2 into 22 by 7 into r. Let me take the radius of the circle as r. R is equal to 44. I'm equating it to 44 centimeter. Now I can easily solve for r. What will be the value of r? I can cut this 2 into 22 with this 44. So I will have r is equal to 7 centimeter. So very simple. We got the value of the radius of the circle, 7 centimeter. And with this, now we can find the area of the circle. So area of the circle will be what? Pi r square, is it or not? Yeah, yes. Now pi r square will be 22 by 7 into, what about the radius? Just now we got it, 7 into 7. So now we can cut this 7 and 7. So I'll be having 22 into 7, which will be 4, 14, 1, 15. So 154 centimeter square. Okay, because we are finding the area, we should be careful with the units. 154 centimeter square. So this is going to be the area of this circle. 154 centimeter square is going to be the answer for your question number 15. Now we are with question number 16. In the adjoining figure, ABCD is a square of side 21 centimeter. So you can see the figure here, and also you can see a square ABCD here. Okay, and it is given that the side of the square is going to be 21 centimeter. So which means this AB is going to be 21. Okay, 21. BC is 21. CD is 21 and AD is also 21. Okay, it is clearly understood like that, because square, all the four sides are equal. Continue the question. AC and BD are two diagonals of the square. So they are forming the two diagonals. AC is a diagonal, BD is another diagonal. Now here at this point we need to understand few important properties of, we need to recall few important properties of square. Okay, now whenever we have a square and we draw two diagonals, always the property is the two diagonals will be intersecting each other, or they will be cutting each other at right angles only. Okay, fine, yes, they will be cutting in a perpendicular way. Okay, yes. And point number 2 is the two diagonals bisect each other. So they will be bisecting each other. What do you mean bisect? So this diagonal will cut this one into two equal halves, and the same way the other way also it is the same. This diagonal will cut this diagonal into two equal parts. Okay, fine, yes. Now because of which what will happen is you will be able to see four triangles formed here. Is it or not? Yes, the four triangles are formed here. If you want, I will clearly tell. If the center point is so, I mean the points where the the point where the diagonals cut each other, if I name it as O, then you will be able to see 4 triangles, and all of them are going to be what? They are going to be isosceles triangles. Okay, right angled isosceles triangle. Why? Because each of these angles will be 90-degree inside, and also the sides will be equal. These two sides will be equal. That's why. Okay, just see the 4 right angle triangles clearly here in this picture. AOB is a triangle, BOC is a triangle, COD, and then AOD. So these are going to be the 4 equal sized and also at the same time right angled isosceles triangle. Okay, fine. So this is some important property we need to recall, which we will be using here to solve the problem. Okay, fine. Anyways, we'll continue the question. Two semicircles are drawn with AD and BC as diameters. Now with AD as diameter, here a semicircle is formed. That side BC as diameter, that side also another semicircle is formed. Okay, yes. Now finally, what is the question? Find the area of the shaded region. So this is going to be the question. So you can see some region is going to be shaded here. We need to find the area of the shaded region, and we are also given use the value of pi as 22/7. This is given. Okay, yes. Now shaded region will come to now observe about very clearly about the shaded region. Now listen very carefully. What about the shaded region here? Shaded region. Here these two semicircle regions are shaded, and then inside the square 2 of the triangles are also shaded. And it is important to understand that the diameter of the semicircles, these two semicircles, it's going to be same as the side of the square. Is it or not? That means the diameter of the semicircles are going to be what? 21 centimeter only. Okay, 21 centimeter. So we'll note it here itself. Diameter of the semicircle is going to be 21 centimeter. Okay, yes. And now another important thing, once the diameter is 21 centimeter, what about the radius? Radius will be half of that. So 21/2 centimeter. Okay, yes. Let me not convert to decimals and all. I will have it as it is 21/2 centimeter. Okay, yes. Now coming back to the shaded region. Now see what I'm going to do. What I'm going to do, clearly you have a close look. Okay. Now we have two triangles. Two triangles. What are the two triangles? We have a triangle here AOD, correct? AOD is there. And then the other one is BOC. BOC is there. So this way we have two triangles. Fine. Okay. These are the two triangles. This area plus. And what about the next one? Here we have two semicircles, right? So one semicircle with diameter AD is here, and the other one is with the diameter BC is there. So now when I add all these areas, this will give you the total shaded regions area. That's it. Okay. Yes. Now see what are the changes I'm going to do now, or adjustments I'm going to do now. Okay. Listen very carefully. Come to this two triangles area region. Now these are the two triangles that you can see in the picture. Now just how we discussed, these 4 triangles will be of equal in area. So let me do a small shift here. Okay, I'll do a small shift. Since all these 4 areas are equal, let me just shift this BOC triangle. You see this BOC is there, no? This BOC, let me shift it and keep it like this. I'm keeping it in the place of AOB. You understand the point? Yes. Are you clear with the structure? Okay. I repeat, BOC, I'm just shifting it here. That's all. You keep that the shaded region is not here. That shaded region is now shifted to this AOB region. That's all. This is what all I come to tell. So now what will be the new look of your shaded region? Now your new look will be, it will be looking something like this. This is how it will look. Is it or not? So A will be here, B will be here, and D will be here. I hope you understand this. Now these two triangles will now form a new structure like a big right angle triangle, something like this. And remember that for this right angle triangle, what about the two sides here? No doubt, this is also 21 centimeter, this is also 21 centimeter. That's it. Okay. Plus, same way. Now see these two semicircles. Now these two semicircles area also we are going to add, which means I can just join these two semicircles. It will now form what? It will now form a one single circle, and one single circle whose diameter will be 21 centimeter, which means the radius will be what? The radius will be 21/2 centimeter. That's all. So now the shaded region now became area of this big right angle triangle plus area of this circle. Now once I do this, I can easily get the answer. Yes, fine. Now continue this. Area of this right angle triangle will be what? Remember, it is a right angle triangle. Okay, yes. Why? Because when you shift it here the angle formed, it's actually the one part of a square only, right? So which means the angle will be definitely a 90 degree only. So here this right angle triangle area will be half into, what about the base and height? Base will be 21, height will be 21. So half into 21 into 21 plus, now here this side area of the circle also we know pi r square. So pi is 22 by 7 into, what about r square? R is 21 by 2. So 21 by 2 into 21 by 2. This is what we have. Correct? Okay. Yes. Now we need to simplify this. So how can this be simplified? Yes. Okay. Okay. Let me do something. I will take 21 by 2 as a common factor outside. Okay. So I will take 21 by 2 as a common factor outside, because here also I have 21 by 2. Here also I have a 21 by 2. So I'm just removing this 21 by 2 and this 21 by 2 outside. And also you can see here I have what? Here I can cut this 2 and 22 for 11 times, 11 and 21 for, sorry, 7 and 21 for 3 times. Okay. So yeah, this is 11 times, this is 3 times. So I will have, inside I will be having 21 plus, here this is 21 alone will be left, 21 plus, here 11 3s are 33. So that means I will have 21 by 2 multiplied by, now what about 21 plus 33? This will be 54. Now once again I can cut this 2 and 54 for 27 times. So this will finally give you what? 21 into 27. So what about 21 into 27? We'll multiply it. 21 into 27 will be 1 7s are 7, then 7 2s are 14, 2 1s are 2. So 14 plus 2 will be 16, then 1 carry, and finally 2 1s are, sorry, 2 2s are 4, 4 plus 1 is 5. So 567. So what about the units? Everything is there in centimeter only. So that means centimeter square. So area of the shaded region is going to be 567 centimeter square. I hope the construction is clear to you. We just made some small adjustments here in this diagram so that we can do the problem in a comfortable way. That's the reason. Okay, yes. So all these adjustments are done. Then we do the problem with our known usual formulas only, and we get the answer. So 567 centimeter square is going to be the answer for your question number 16. Now we go to question number 17, subdivision A. In the given figure, OAB is a quadrant of a circle. So you can see the figure here. So this figure, okay, this shape what you see here, OAB is a quadrant of a circle. So what do you mean by quadrant? So quadrant means basically quarter portion of a circle. Okay, fine, yes. And it is important for us to know the area of a quadrant. So area of a quadrant will be quadrant. The area is going to be very simple. For a full circle, the area is going to be pi r square. We know that very well. This is a quadrant, so quarter portion, right? So quarter, how do you write it as a fraction? We write as 1 by 4. So 1 by 4 pi r square is going to be the area here, okay? And it should be noted that quadrant means quarter circle. So which means this angle what we have here, it will be a what? It will be a right angle, 90 degree, okay? Yes. Okay, continue the question. The radius OA is 3.5 centimeter. So they gave the radius is 3.5. So this will be 3.5 centimeters. So this measure. And same way, what can I tell about OB? OB will also be same 3.5 only. Is it or not? Yes, 3.5 centimeter. Because this is radius. This is also radius. Okay, yes. And OD is equal to 2 centimeters. So they also gave the measure of this OD, which you can see here. OD is going to be how much? 2 centimeter. Okay, yes. And now the question is calculate the area of the shaded portion. Very simple question. Very simple. So shaded region area we need to find. So just again think of, to find the area of the shaded region, what are all the things we need? Or just think like from which portion, if I remove which portion, we'll be able to get the area of the shaded region. That way we have to think it. Okay. Now look at here. Here, in order to find this shaded portion, this portion is inside the quadrant, but it is outside the triangle OAD. Is it or not? And remember that OAD is a right angle triangle. So which means to find the area of the shaded region, I can simply do the quadrant's area. Okay. Quadrant area minus the triangle area. Triangle means right angle triangle, what we see there. OAD, that triangle area, if I do, I can easily get the answer. So this will be nothing but quadrant's area is 1 by 4 of pi r square. Is it or not? So 1 by 4 into 22 by 7 into, what about r here? R will be 3.5, right? So now let me do something here. I will write this 3.4 as, okay, radius is 3.5. I'll just take it as 7 by 2 centimeter. Okay, fine. It's 7 by 2. So 7 by 2 into 7 by 2. Now from this, minus, okay, minus, I don't have extra space here. So minus. Now what about the triangle's area? Triangle area will be half into base into height. So half into, what about the base and height here? So here the base of the triangle is again 3.5. So 7 by 2 multiplied by height of the triangle is going to be 2 centimeters. So this will be 2. That's it. Okay. Now once you simplify this, you will be able to get the answer to this question. So let's carefully simplify this. First of all, if anything we can cancel, we'll do it here itself. So I can very well cut this 1 7 with this 1 7. And next I can also cut this 2 with 22 for 11 times. I can cut it. That's all. No other things I can do here. So I will be having 11 7s are 77 divided by 4 2s are 8. 77 by 8 minus, here come here I have 1 2 and 1 2 I can cancel, and I'll be left with 7 by 2. So 7 by 2 I'll be left with this one only. And so finally I will be having 77 by 8 minus 7 by 2. I can take the common multiple to be 8. LCM is 8, right? 8 and 2 LCM is 8. So I will be having 77 minus, here this 2 I need to multiply it by 4. 2 4s are will only give you 8. So do the same to the numerator also. 7 4s are, so we'll be getting 28, correct? Yeah. So I will have 77 minus 28. So 77 minus 28 will be, first I will have a 9 because I can carry this. 17 minus 8 will be 9. So here I will have only 6. 6 minus 2 will be 4. So 49 by 8 will be the answer. Now 49 by 8 will be what? 49 by 8 will be basically 6, because 8 6 are 48 I will have, and I will have a balance remainder 1. So 1 by 8 will be what? 0.125. Is it or not? So my final answer will be 6.125 centimeter square, because we are finding the area, shaded area is what we are finding. So my answer will be in centimeter square units. So 6.125 centimeter square is going to be the answer for your question number 17, subdivision A. Now we have the same 17th question, but subdivision number B, the next subdivision. In the given figure, ABC is an isosceles triangle with angle ABC is 90 degrees. So listen carefully to this diagram. Here is where we have a triangle ABC, and also it is given that it is an isosceles triangle. Okay, ABC is an isosceles triangle, and you see here this is given that angle ABC is 90 degree, which means what we can understand is this angle B. Okay, angle B is what is that? 90 degree. So 90 degree means that is how we will be giving the notation, right? So here we can understand that it's a 90 degree, and also it is an isosceles triangle. So that means what we can understand here very clearly is these two sides, that is AB and BC, they must be equal. Is it or not? Yes, fine. Okay, anyways, we'll continue to verify it. A semicircle is drawn with AC as diameter. So we have this triangle ABC. Now with this AC, this side AC, by keeping that as the diameter, they have drawn a semicircle. Okay, that connects the point, or that touches the point A, B as well as C. That way they have drawn a semicircle. And if AB is equal to BC is equal to 7 centimeter. So listen very carefully. AB is 7 centimeter, BC is also 7 centimeter. Then what is the question? Find the area of the shaded region. This is going to be the question. Okay, as usual, we need to find the area of the shaded region only. So this is going to be this question. So let's make some clear plans here. Now first of all, it is very clear that we have a right angle triangle, and the base and height of this right angle triangle are going to be 7 centimeter each. That is clear. Now let's think about this semicircle. For the semicircle, what about the diameter? AC is the diameter. Now what would be that AC? What will be the length of that AC? Very simple. This AC is actually the third side of this right angle triangle also. Is it or not? And also it should be noted that our triangle ABC is an isosceles right angle triangle, which means we remember the ratio, right? We remember the three sides of an isosceles right angle isosceles triangle. A, that means the third side, the hypotenuse will be A root 2, which means here 7 means our AC should be 7 root 2. That's it. That means now we can connect it with our semicircle. For our semicircle, the diameter, AC is the diameter, right? So AC diameter will be 7 root 2. That's it. Okay, fine. So diameter of our semicircle will be 7 root 2, which means what about the radius of our semicircle? It will be 7 root 2 divided by 2. That's all. Okay, understand? Is the point clear to you? So this is what we can arrive. And okay, 7 root 2 by 2 centimeter. Let us not simplify this now. We will have it as it is. Now coming to the shaded region area. So how can we find the area of the shaded region? Now we will have some observation. Now the shaded portion is actually inside that semicircle only. It is inside the semicircle but outside the triangular region. So which means to find the area of the shaded region, we will do a very simple plan. From the semicircle area, okay, area of the semicircle, from this we will minus the area of the triangle, right angle triangle. Now if we do this, we will be easily able to get the area of the shaded portion, is it or not? So semicircle area, from that I am removing the triangles area, that means I will be left with only the remaining portion, which is what is the shaded region. Okay, yes. Now area of the semicircle, what about the area of a semicircle? For a full circle the area will be pi r square, but this is a semicircle. Semicircle means half. So 1 by 2 of pi r square. Okay, so pi r square means 22 by 7 into r square. So what about the value of r? R just now we saw, right? So r value will be 7 root 2 by 2 into 7 root 2 by 2. This is what will be the area of the semicircle. Now minus this value minus. Now what next I can do here is area of the triangle. Now what about the area of the triangle? This will be half into base into height. Now what about the base and height of our triangle? It's a right angle triangle, so base is also 7, height is also 7. So half into 7 into 7. That's it, very simple. Now let's clearly simplify this in order to get the answer, right? Okay, yes. Okay, first of all what I will do is I will just cut this 2 and 22 for 11 times. Listen carefully, 2 and 22 11 times in the numerator. And next what I will do is I can also cut 1 7 with one of these 7s. That also can be done. And what other things am I left with? I am left with root 2 into root 2 in the numerator. Now think about root 2 into root 2, it will be making a 2, correct? So root 2 into root 2 will make a 2. I will cancel with one of these 2's. Is the idea clear? So these are all the cancellations I can do here. So I will be now left with, what are the other things left in the numerator? I am left with 11 into 7. So 77 divided by 2. So 77 by 2 is what I am left with, this first one. Okay, so let's check it carefully. So 11 is here. So here 7 is here. 11 7s are 77. And denominator portion I have only 1 2. Okay, yes. Minus. Now coming here what I have, half of 7 into 7. I cannot cancel any numbers here. So 7 7s are 49. So 49 by 2. Now all I can do is I can do 77 minus 49 whole divided by 2. So this will give you how much? 77 minus 49 will be 28, right? So 28. So 28 by 2. So 28 by 2 will be 14. So 14 centimeter square will be the answer. Okay, I think the construction is very clear to you. We have a triangle and covered by that you have a semicircle, and we need to find the area of the shaded region. For that is what we are doing, semicircle's area minus triangle's area. So for that semicircle alone, you need to be very careful with the diameter and radius. That we are doing the calculation and getting the answer, and from there it follows everything with the basic formulas whatever we know. So 14 centimeter square is going to be the answer for your 17th question, subdivision B. We have question number 18, subdivision A. The quadrants shown in the given figure are each of radius 7 centimeter. So now look at the figure here. Here we have got 4 quadrants. Now if you closely look at here, by keeping this point as the center, you have a quadrant like this. Same way, by keeping this point as the center, you have a quadrant like this. Again, here center one quadrant and here center one quadrant. So they have made 4 quadrants here. Okay. So maybe for comfortability, we'll just name it, okay, Q1, Q2, then Q3, Q4. These are going to be the 4 quadrants. And we very well know what you mean by a quadrant, right? We also solved a problem just before. So quadrant means quarter portion of a circle, 1/4 of a circle. And also it is given each of this quadrants we have the radius is 7 centimeter. Okay, so radius is 7, that also we will note it, 7 centimeter. Okay, fine, all right. Now next, what is the question is, then calculate the area of the shaded portion. Now if you see, they have enclosed some region here in between. That in between region is what is shaded. We need to find the area of the shaded portion. This is going to be the question. Okay. Now again, this question also without any complications, we will try to solve it in a very convenient way. Now again, look at the diagram very carefully. So now if you see this clearly here in this given figure, we will be able to see a square first. So there's a big square. You can see a big square here, and the four vertices of the square are going to be the center points of those quadrants, because by keeping those four vertices of the square only, they have drawn the four quadrants. Fine. Okay, all right. Yes. So that means we have a big square, and let us now think of what will be the side of this square. Okay. Now what about the side of the square? We can tell. Now each quadrant we have the radius is 7 centimeter. That means, what is the meaning? That means this radius, the radius what is drawn here, each of them will be 7 centimeter. That means this is 7, this is 7. Is it or not? That means this full side will be 14 centimeter. It's very clear. Correct? Okay. So side of the square is 14 centimeter. This structure is clear. Now let us again think of, to get the area of the shaded region, what has to be done here? From the area of the square, if I just remove or minus the area of these four quadrants, we will be able to get the area of the shaded region. Is it or not? So that means, let's make the plan very clear. Shaded region area will be nothing but area of the square. Okay, area of the square minus 4 times of the quadrants, and it should be noted that all the four quadrants are of equal size. So it means 4 times of the area of the quadrant. This is what we have to understand here. Okay, fine. Yes, now the plan is very clear. Now once again, if you see, square area is very simple. Area of the square is very simple. And minus. Now what can you think about the four quadrants? Because one quadrant is quarter portion of a circle. Now if four quarters come to join, what will be getting here? We will be getting one full circle. That's it. Very simple, right? So we will be getting a circle. That means this problem is going to be very simple. To get the shaded region area, we just need to take the area of the full square and subtract the area of one full circle from there. Okay, where side of the square is what? Because area of the square is going to be side into side. Side just now we calculated 14. That means area of the square will be 14 into 14. From this we should minus the area of the circle. Area of the circle also we know very well, pi r square. So pi r square will be what? 22 by 7 into, we also know what is r here. R is the radius 7. Okay, so 7 into 7. Now simply we do this, we will be easily able to get the answer. Now what is 14 into 14? 14 square is 196 minus I can cut 1 7 here. So 1 7 with this 1 7. So I will be left with 22 into 7. So 22 into 7 will be 154. Is it or not? So now when I subtract it, what will be the answer I will be getting? I will be getting 6 minus 4 is 2. And then this is 9 minus 5 will be 4. So 42 centimeter square. So 42 centimeter square is going to be the answer for your question number 18, subdivision A. Now we have question number 18, subdivision B. In the given figure, a square OABC is inscribed in a quadrant OPBQ. So now listen carefully with the to the diagram. Now we have a square. We are able to see a square here. Square ABC, OABC. Okay, OABC is a square, and this square is seen inside a quadrant. Quadrant OPBQ. Okay, fine. Yes. So square inside a quadrant. So this is going to be the structure of this given figure. Now what else is given here? Okay, OPBB, quadrant of a circle. So yeah, of course it's a quadrant of a circle. And if given OA is equal to 20 centimeter, so they are given OA, that is the side of the square, is going to be 20 centimeter. Okay, so 20 centimeter is actually the side of the square alone. Okay, don't confuse it with the radius of the quadrant. So radius is OP actually, correct? But they are given OA is 20 centimeter. So it means we should understand that the side of the square is 20 centimeter. That means what is the meaning? AB is also 20. This BC is also 20. This OC is also going to be 20 only. All four sides of the square are equal. Yes. Now the question is find the area of the shaded region. So again we are asked to find the area of the shaded region. Now looking at this structure, you can easily observe that this shaded region is there inside the quadrant but outside the square. That means how can we find the area of the shaded region? Very simple. We can just take the quadrant's area. So quadrant's area. From that we can just subtract the area of the square. That's all. Fine. And we know how to find both the things. Quadrant of a circle. How do you find the area of the quadrant of a circle? It's very simple. It's simply 1 by 4 pi r square. Is it or not? Where r is going to be the radius of the circle, I mean the quadrant, minus area of the square also we know a square. That's all. Okay. Yes. So now we need to find the this expression. This will give you the answer. Now here there is no problem with the side of the square. A we already know. Okay. So A is what is the side of the square, right? So A is going to be 20 centimeter. So no problem with this. But now what about the radius of the quadrant? It is not available here, right? So then how come we find the area of the quadrant, sorry, radius of the quadrant? How can we find this? Now again have a close look to this picture, okay? Now let's take this r to be the radius of the quadrant. I am taking it to be r, okay, r. Now r is nothing but this OP is going to be r, correct? So this OP is what is r. So r, or otherwise I can even tell this OQ is also going to be r only, correct? This measure is also going to be r. Then have a close look again. There is something else also here r. What is that? Very good. This OB, if I try to draw a line or connect these 2 points O and B using a straight line, this line will also, the line OB which I have drawn in the red color, this also stands for R only. Is it or not? This is going to be, this also is going to be R only, because from center to any point on the quadrant is going to be R only, correct? So in that sense OB is also R. Now we will try to find this OB now. Fine, okay. Now if you look at this OB, that OB is going to be radius for the quadrant, and at the same time this OB is what for the square? Can you see? It is nothing but the diagonal of the square. Is it or not? And of course I can even tell this OB is actually a portion of a right angled triangle, that too right angled isosceles triangle. Why? Because this angle is going to be a 90 degree. Is it or not? That means this is 90 degree. I know this OA base is going to be 20. And this AB is also side of the square only. This is also 20. So which means this triangle OAB, what you see here, is going to be a, it's going to be an isosceles right angle triangle. That means if these two sides are 20 each, then what will be the hypotenuse? That means R. What will be that? Very simple. It's going to be 20 root 2 centimeters. So radius of the quadrant is going to be 20 root 2 centimeter. Very simple, right? So we know the basic property of right angled isosceles triangle. A means the third side hypotenuse must be equal to A root 2. The same property is what we are again using. 20 means this side will be 20 root 2, and of course that is going to be what? That's nothing but the radius of the quadrant. That's it. Now we got everything we want. Just substitute it here and we get the answer. Now 1 by 4 into, what about pi value? Pi, they have asked us to take pi as 3.14. So let's take the same value, 3.14 into r square. R square means 20 root 2 into 20 root 2, correct? Yes. Now minus a square. A is nothing but the side of the square, which we already know, 20. So 20 square. That's it. So now what next we can do here is, we can just try to cancel any possible values here actually. So what numbers we can cancel here is, okay, I'll try to cancel this 4 and then 20. This is going to be, of course, how many times it is? It's going to be 5 times, correct? Yes. And now I have 3.14 into I have a 5 root 2 into 20 root 2. Now 5 into 20 will give you 100 into this will give you, this root 2 into root 2 will give you 2. minus 20 square is 400. I hope you are able to understand this. I repeat, I cancelled this 20 and 4 for 5 times, and this 5 I multiply with this 20 gives you 100, and root 2 into root 2 is 2. That's it. Okay. Now continue this. I can multiply 3.14 into 100. This will give you 314. Now 314 into 2 will give you 628. Very simple, right? So 628 minus 400 will finally give you 228, and of course the units will be centimeter square. So we are finding the area. So units will be 228 centimeter square, and of course, yes, this is going to be the answer for your question number 18, subdivision B. Now next we have question number 19, subdivision A. In the given figure, the points A, B and C are the centers of arcs of circles of radii 5 centimeter, 3 centimeter and 2 centimeter. Now let us see the given picture, the given figure. Now we can see a big circle here. Okay, yes. And also inside that we have a shaded portion. Let's carefully observe the shaded portion, how it is. Now here if you see, we are able to see a semicircle here. Is it or not? Yeah, fine. And also there is another semicircle of bottom. I mean the bottom portion of the semicircle is available. Here the top portion is available, shaded. And here the bottom portion of a semicircle is also available, that is unshaded. Now this is going to be the structure. And if you closely observe, there is one big circle. That big circle's center is what? Is this A. And what they are given? They are given the radius. Okay. And how they are given? We will see it one by one. The big circle center is A. So let me do something. I will take the radius of the big circle as RA. And that is given to be what? Radius of the bigger circle. I mean point A center. By keeping A as center, the radius is 5 centimeter. Okay, so this is going to be 5 centimeter. Okay, yes. Now next is by keeping B as center, we have another circle. So B as center, we have this circle is drawn, which means this semicircle portion corresponds to this center B. And we will take radius of that circle as RB. And that is given to be what? RB is 3 centimeter. Okay, so we'll note it here 3 cm. And last, we have another circle whose center is C. Center C, this is the semicircle. Okay, fine. So that radius we will take it as RC, and that is given to be 2 centimeters. Okay, yes, fine. Now everything is clear to us. Now finally, what is the question? Find the perimeter and area of the shaded region. Now this shaded region's perimeter and area, both the things we need to find. So that's why I made it separately. Okay, this side we are going to find the perimeter, here area. Okay, yes. Now it is very clear that what portion is shaded. Now listen very carefully. The region which is shaded is enclosed by 3 arcs here. Listen here carefully and see that. Okay. Now this portion, okay, this portion if you see means here the boundary is the arc of the semicircle whose center is B. And here we have another border. This is bulged up. Okay, and here this semicircle, this arc is from the semicircle whose center is C. And here we have the other semicircle whose arc is going to be of, what to say, I mean the arc is from the semicircle of whose center is A. That's all. Okay, now these are the bounded regions. Here one semicircle, here one semicircle, here one semicircle. Now in order to first of all find the perimeter, what is that we have to go for? We need to add all the arc lengths of these 3 semicircles. Now when we do that, we can find the perimeter. Is it or not? That is I'll name it like this itself. Okay, arc A plus arc B plus arc C. We'll have it like this. It will be easy for us to understand, right? Where arc A is what? Arc A is this big arc. Arc B is this one and arc C is this one. Now when I add all the 3 values, that gives you clearly the perimeter of the given region. Okay, yes, so this will be equal to, now think about what will be the arc length. It's very simple to see again. Since these shapes are semicircles, what can be the arc? Arc will be nothing but half of the circumference of the full circle. That's all. Okay, fine. Yes. Why? Because these are all semicircles. For our full circle, we know the circumference formula. It is going to be 2 pi r. That means this will be what? So if better I will write it here itself. So for a full circle, the circumference will be 2 pi r. Now For the semicircle, the arc length will be what? It will be half of this 2 pi r. So half of 2 pi r will be nothing but simply pi r only. Is it or not? Yes. So that means we will use that formula itself directly here, pi r. Okay, yes, fine. Now come here. Here arc A, that means here pi into, what about the corresponding radius of circle A? That is what we have written it as RA, correct? So pi into 5 plus arc B is going to be pi into, for this one the radius is 3, and finally arc C, for this one the radius is 2. Okay, yes. So now when I totally add it, I will be getting what? 5 pi plus 3 pi plus 2 pi. This will together give you 10 pi, correct? Yes, fine. And now the next thing is, they have asked to use pi as 3.14 in the question. I'm sorry, I missed it. So pi, we need to use it as 3.14 for this particular question. You can refer the book and see. So that means we will be getting the answer as what? 10 pi means we have to do 10 into the 3.14. So we will be getting 31.4 centimeter. Okay. See very carefully, we are finding the perimeter. So in that case, we will be having the units as 31.4 centimeter. That's it. Okay. Yeah, now coming to the next portion, area. Now we need to find the area. Now what about the area? Area of the full circle will be pi r square. But here we are going to find the area of the half a circle. I mean, we need to find the area of the semicircle only. So area of the semicircle, okay. So semicircle area will be nothing but what? Half of this pi r square. That's it. So half of pi r square will be the area of each of these portions. Is it or not? Because we have 3 semicircles only. Is it or not? 3 semicircles are there. That means we need to do the calculation very carefully. Okay, yes. But hold on here. We need to listen to this diagram very carefully in order to find out the area of this portion. Okay. Now listen very carefully what I am going to do. Now to find the area, just think of what calculation we need to do here. What calculation we need to do here? We need to consider this area. I mean the area of the semicircle whose center is C, that we have to take. And what next we have to do? See here, this portion is unshaded, correct or not? That is the semicircle whose center is B, that semicircle region is not shaded, it is unshaded. So we will do something. Let me take the area of this semicircle, the full semicircle, I mean with center A. I will take that semicircle's area. From there, I will minus this semicircle. Is that clear? So when I do that, what happens? From this entire semicircle, this portion alone will be removed off. That means this will be unshaded. That's it, very simple. So that means together what happens if I put everything together to find the total area, what will be the answer? Our answer will be, so area of, okay, area of, so let me take it like this, okay, A suffix A, which means area of the circle with center A. From there, what we have to do? We should do minus area of the circle whose semicircle whose center is B. I hope you are able to understand why we are doing minus. We should not add it, okay? We should do minus. Why? Because out of this area, we are removing this area because that region is not shaded. It is unshaded. That's the reason, okay? Yes. So minus AB, then plus AC, area of C. Why? Because here this region is shaded. This is included in that area. So we have to add that region, okay? So this area minus this area plus this area. Okay, fine. This calculation, if we do, we will be able to get the answer. Now this will be equal to, just now we saw, right? What is the area formula? Area of a semicircle is half pi r square. Don't use this formula. This will give you the area of a full circle. We don't have the full circle. Okay, yes. So in that case, we need to find half pi. We need to use that formula only. So half pi r square. So half into, let's do a better thing actually here. So anyways, half pi r square, half pi r square, half pi r square. Everywhere half is only, half pi is going to come. So let me do a thing. I will take that half pi is common outside. Now what we will be having inside? We will be having only r square respective values, correct? Now for the first circle, semicircle, the radius is 5. So 5 square. Then minus, for B it is 3 square. Then last one for C it is 2 square. Is it or not? This is what we will be getting. So now again what we do? Half into, so pi is as usual 3.14 into let's straightly calculate this value. Okay, when we do this, we will be getting what? 5 square will be 25. Okay, I think I can use this space. I'll just put a line. I'll use this space 25. Then minus 3 square will be 9. Then plus 2 square will be plus 4. Is it or not? So now when I do this calculation, I will be getting what? I will be getting 20, correct? 20, because 25 plus 4 will be 29. Minus 9 will be 20. That's it. So this will be to 20. So I will be getting again here 2 and 20. I can cut it for 10 times. So I will be getting 10 into 3.14. So again we get the same 31.4 to be the answer. But this time we are calculating the area. So be careful with the units. We need to put centimeter square. Okay. So the wonder thing is we get the answers to be same. Numerically they are same. But one is the perimeter, so be careful with the units. We need to use centimeters. The other one is the area, so centimeter square. So of course, so these are going to be the answers for your question number 19, subdivision A. Now we have question number 19, subdivision B. The figure given shows a kite in which BCD is in the shape of a quadrant of a circle of radius 42. So you can see the figure of a kite here. And also it is given that BCD, okay, just see here. So BCD, this is actually in the form of a quadrant. That's what they are given, okay, quadrant of a circle whose radius is 42 centimeter, okay. So that means what we can understand here is by keeping the C as center, they have made this arc BD. That's what we have to understand, okay. And what about the radius here? Radius is 42 centimeter. So I'll put it here. This is 42 cm. And here also, this also 42 cm, okay. Yes, fine. And what next is given? So it is also given that ABCD is a square. So ABCD. So this shape ABCD is a square they give. And triangle CEF. See, this is triangle CEF. Okay. Where is triangle CEF in this picture? See at the bottom. You can look, a small triangle is here, right? This is triangle CEF. And they are telling that that triangle is an isosceles right angle triangle whose equal sides are 6 centimeter long. Okay, yes. So that means this CEF is a right angled isosceles triangle and equal sides. What about the equal sides? Equal sides are 6 they are given. Now we need to understand here something. Once this is quadrant, this angle will be 90 degree. Okay, fine, yes. And also this opposite, this angle also must be 90 degree. Is it or not? By the way they gave the question itself, we can clearly understand it. That is, they gave what? Right angled isosceles triangle. That means these two sides, the CE and CF, are going to be equal sides. So what we can take is those equal sides are what? They are given to be 6 and 6. Okay, understand? Yes. Now finally, what is the question? Find the area of the shaded portion. This is going to be the question. So although the question is very long, the way of solving this question is going to be very easy only. Now listen here, what easy steps we are going to do. So here actually, to find the area of the shaded region, it's very clear and open that there's nothing to do with this full square. Now to find the area of the shaded region, all we need to do is just take the area of this quadrant portion, the quadrant of the circle, and add it with this bottom small triangle. That's it, okay. So area of the quadrant plus area of this triangle, okay, I mean triangle CEF. Now just if we find these two areas and add it, that itself is enough. We'll be able to get the area of the shaded region, right? Okay, now let's do the process. Now what about the area of a quadrant? We have seen many problems before. Area of a quadrant, how do you find it? We'll be finding it as 1/4 of, because quadrant of a circle means, it means quarter, 1/4 portion of a circle. So 1/4 of pi r square. So 22/7 into, what about r square here? What is r here? R is 42, radius is 42. They also mentioned there in the question, right? So 42 into 42 plus, now we'll come to this triangle CEF. Now how to find the area of the triangle CEF? And that is also very clear that it is a right angled isosceles triangle. That means we can directly use half into base into height. Now when we have a right angled isosceles triangle, what about the half into base into height? The base and height are going to be what? Very simple. No need to confuse it. Confuse here. The equal sides, we can take them to be height and base. That's it. Okay. So half into base is 6 and height is 6. Very simple. Make it very simple. Okay. That's it. Now once we do this, we can easily get the answer. Now see how we are going to solve this problem. So first of all, what we can do here is I can just cut this 4 and 22. So this will be 11 times and here it will be 2 times. Now once again what I can do is I can cut 2 and 42 for 21 times. Again this 7 and 21 for 3 times. That's it. Okay. So now I will be getting 11 into 3 into 42 because all the denominators got cut. So 11 into 3 into 42 is what is left over, plus now here what we have, here we have 2 and 6. I can cut for 3 times, so 3 6 are. So now simply we have to multiply these values clearly and add it to get the final answer. So first we will finish off this. So here I will have 11 into 3 into 42. First of all, what is 3 into 42? So 3 into 42 will be 126, correct? So 126 into 11 we need to do. So 120, because this will be 126, and 126 into 11 will be 6. 6 plus 2 8, 2 plus 1 3, and drop this one as it is. Just that's it. 1386 plus here. What about 3 6 are? This is going to be 18. So simply if I add these values, I will be getting the final answer. So this will be nothing but 6 plus 8 will be 4, 14, 1 carry. Then 8 plus 1 will be 10. Again 1 carry, 4, and then 1. So 1404. What about the units? Centimeter square. So 1404 centimeter square is going to be the answer for your question number 19, subdivision B. We have question number 20, subdivision A. In the given figure, a piece of cardboard in the shape of a trapezium ABCD, and given AB is parallel to CD, and angle BCD is equal to 90 degrees. So these are given information about this trapezium ABCD. Now we'll have a look at this in the given figure. Now this is what is the trapezium ABCD. We know the basic properties of a trapezium. So we will have 4 sides and 2 opposite sides will be parallel. So here also they are given very clearly. The sides AB and CD are parallel. Okay. So this sign they will be using to mention parallel. Okay. Yes. So this AB and CD are parallel, they give. And what next is given? We also have a quarter circle, a quarter portion of a circle, BFEC is removed. Now from this trapezium they are removing a quarter circle portion. Okay, BFEC. So BFEC, this quarter circle is removed out of the trapezium. This is what is given. Now what else is given here? We are given some measures here. Let's have a close look. Given AB is equal to BC is equal to 3.5 centimeters. So AB is here 3.5 centimeter. We'll note it here. And BC is also same 3.5. Okay. So BC is also 3.5. Now when BC is given to be 3.5 centimeter, it should be noted that this BC is nothing but what? That's the radius of that quarter circle, the quadrant portion of that circle. Okay, so we'll note it here itself. So the radius is, okay, R is going to be 3.5 centimeter. So our R is going to be what? That's the radius of our quarter circle. Okay, yes, we'll have it in one side. And also it is given what? DE is equal to 2 centimeter. Okay, now this portion DE is going to be 2 centimeter. See, this is only about DE. Okay, DE is 2 centimeter. Fine. Okay, then finally what we need to find? Calculate the area of the remaining piece of the cardboard. That means the shaded region is what we need to find, because from that full cardboard ABCD, if you cut this shape, okay, if you just cut this quarter circle portion, what will be the remaining portion? The shaded region is what is the remaining portion. So we can clearly tell that shaded portion, the remaining region is nothing but the area will be the shaded area only. This is what we need to find now. Okay, yes. Now let us again have a close look. Now just see here, we have a trapezium basically. Trapezium with AB and CD are 2 parallel sides. Now what about the 2 parallel sides? How we usually take it? We will be taking them as A and B. That's how we take, correct? Yes, the 2 parallel side we will be taking it as A and B. Now A, let us have this AB to be A. So AB is very clear, it is 3.5 centimeter, no doubt in that. Now what about the CD? Because that is what is our B. The other parallel side is going to be CD, this CD. Now what will be the CD actually? The CD is nothing but this EC plus DE, is it or not? Already DE is 2 centimeter, but what about EC? EC, no confusion here. EC will be nothing but again the radius of this quarter circle only. So that means the same 3.5 will come here. So 3.5 centimeter. Okay, yes, fine. Now we can tell what is this entire CD. This side CD will be 3.5 plus 2, which will be 5.5 centimeter. So B will be 5.5 centimeter. So A is 3.5 centimeter, B is 5.5 centimeter. And what about the height or h? I mean the perpendicular distance between these two parallel lines. That will be nothing but this BC only. This BC what we see is going to be the height, and that is again going to be 3.5 centimeter. So now we have got all the information, whatever things which are required to solve the problem, everything we have it with us now. Okay, so trapezium's information is available and the quarter circles information is also available. Now we'll again think about what will be the shaded region. Very simple. From this cardboard trapezium, we are removing what area? We are removing the quarter circle area. So if I simply take the trapezium's area from this trapezium, okay, trapezium area, if I minus the area of the quarter circle, okay, I'll write as quadrant of the circle, I will be able to get the remaining shaded regions area. Okay, so yeah, this is equal to, now what about the area of a trapezium? It will be half into height. What about the height? Height is 3.5, right? So 3.5 into, and what will be the a and b values? A plus b, is it or not? So a plus b will be nothing but, so I'll write it clearly, 3.5 plus 5.5. So half into h into a plus b. That's going to be the formula for area of a trapezium, right? We have already seen that. So I've just exactly substituted the values, minus. Now what about the area of a quadrant? That will be nothing but 1 by 4 of pi r square as usual, because quarter circle 1/4 of pi r square. That will be what? That will be equal to 22 by 7 into, now next we have 3.5 into 3.5. Now once we do this calculation, we will be easily able to get the answer. So let's do this calculation very clearly now. So now this will be equal to, let's make some changes if you want. So what I'm going to do now is half into, so this 3.5 I will write it as 7 by 2 into. Now what about this 3.5 plus 5.5? This will be together giving you 9, correct? Because 3 plus 5 will be 8. 0.5 plus 0.5 will be 1. So 8 plus 1 together 9. That's it. Minus. Here also let's do a same kind of thing. 1 by 4 into 22 by 7 into this 3.5s. Those two 3.5s also I will replace it as 7 by 2. I'm just avoiding the fraction, decimals. To make it as fractions only, I'm doing all these adjustments. Now we will do the simplification process. Now when I try to do the process, here I will not be able to cancel any numbers. So I will be simply having 7 9s are 63 by 2 2s are 4. This is all I can have here. Now minus. Now come here. Here we can do some kind of simplification. I will cut 1 7 and 7. And what next I can do? I can also cancel 1 2 with this 22 11 to get 11. Okay, yes, fine. So that means that's all I can do. No, nothing else I can do here. So that means here I have 11 7s are 77 divided by 4 2s are 8. I hope you are able to understand this simplification. Now I will take the LCM and do the simplification process. So here denominators are 4 and 8. So the common denominator I will take it to be 8. So here it is 63, right? So 4 2s are 8. So do the same here. 63 2s are 126 minus 77. So this will be nothing but, so I will write it here itself. So this will be nothing but 126 minus 77 will be nothing but, so I will have this to be 16. So 16 minus 7 will be 9, and this 12 will be no more 12. This becomes 11. So 11 minus 7 will be 4. So 49 by 8. So 49 by 8, when you try to divide and get the answer in terms of decimals, what do you get here? So 49 by 8 means I can go up to 8 6 are 48, right? So 8 6 are 48 point. What will be the balance? Balance will be 1 by 8. 1 by 8 will be 0.125. So 6.125 centimeter square, because we are finding area. So centimeter square is going to be the answer for your 20th question, subdivision A. Now next we have question number 20, subdivision B. In the given figure, ABC is a right angle triangle with angle B is equal to 90 degree, and given AB is equal to 28 centimeter and BC is equal to 21 centimeter. Let's have a look at the given figure. So this is what they are talking about. Okay, so ABC is it's a right angle triangle, and also here angle B is what is they have mentioned to be 90 degree, and they gave AB is 28 centimeter. Okay, so AB means this measure. Okay, so here to here this measure is 28 centimeter, and then BC is 21 centimeter. Okay, so BC here, this one is 21 centimeter. Fine. Okay, all right. Yeah, let's continue with AC as diameter. Listen carefully. With AC as diameter, a semicircle is drawn. So where is AC here? AC is here. Okay, of course AC is going to be the hypotenuse of our right angle triangle. Okay, now with that AC as diameter, there is a semicircle drawn. You're able to see that semicircle here, right? The outer border, what you see here, that's going to be the semicircle. And with BC as radius, a quarter circle is drawn. Now where is BC? BC is here. Now with this BC as radius, a quarter circle is drawn. Where is that quarter circle? You can see that quarter circle here inside. Okay, understand? So that means there are three figures here. One is the right angle triangle ABC. The other one is there's a semicircle here, the outer one, and there's inside one, this quadrant is here. Quarter circle is here. Okay, yes. Now finally, what's the question? Find the area of the shaded region correct to 2 decimal places. Now we need to find the area of the particular region, whatever is shaded there. For that region, we need to find the area. So this is going to be our question. So as usual, we will take shaded region. Okay, shaded region is equal to, shaded is equal to. Now as usual, let's make the plan. Now when you see the shaded portion, listen and observe very carefully. That shaded portion is inside what shape and outside what shape. As usual, we should make the same analysis. So the shaded portion, you can see it is inside the semicircle. Of course, yes, it is there inside the semicircle, and also some of the portion is also inside the triangle, but it is outside the quadrant region. Is it or not? Is the idea clear to you? Once again, have a close look. Our shaded region is present inside, some of the portion is present inside the semicircle, and some of them is inside the right angle triangle, but the shaded region is not present anywhere in this quarter circle. Okay, that means what can be done? Very simply what we can do is, I will consider the full area of this, the right angle triangle. Okay, so I will consider the right angle triangle area. So right angle triangle, I will simply write as triangle because there's only one triangle here. So triangle's area plus I will also consider the semicircle's area. Okay, semicircle's area, semicircle. Now when you add these two values, you will be able to get the total area of this given figure itself. But we don't want that, we want only the shaded portions area. So for that reason, from this sum of areas, what can be done? I will simply subtract the area of the quadrant portion alone, the quarter circle alone. Okay, so the quadrant region alone, if I remove it out, if I subtract it, we will obviously get the area of the shaded portion alone. This is going to be the plan. Okay, so I think now you are able to relate this. Okay, so triangle area plus semicircle area, if I do it, I'll get the total area. But out of the total area, okay, the entire region will be shaded if I do that. But from that, what is unshaded here? The quadrant portion alone is unshaded. That's why I'm subtracting the quadrants area. Okay, the quarter circles area, I'm just subtracting from this sum. That's it. Okay, yeah, fine. Now let's carefully do the calculations one by one, because we know how to find the area of each of these portions. So let's carefully examine this. First one, we'll start with the triangle. It's a right angle triangle. So for a right angle triangle, how do you find the area? As usual, we'll use the formula half into, what about the base and height of our triangle? Base is 21. So 21 into height is 28. So this will give you the area of this triangle plus semicircle. Now let's come to semicircle. This is what is, we should be doing it carefully. Now what about the semicircle? The semicircle is actually drawn with AC as the diameter. That means first of all we need to find the diameter, right? Now how to find the diameter of this semicircle, that AC? Very simple. AC is basically what? AC is basically the hypotenuse of our right angle triangle. So in that case, I can use Pythagoras theorem to find the value of AC. Is it or not? So AC will be equal to what? It will be square root of, because when I use Pythagoras theorem, what happens? I will have to take the sum of the squares of the other two sides. For that, I need to take a square root. Okay. So if I do it, I will be getting AC is equal to 21 square plus 28 square. So this is what I need to do. So once I do it, I will be getting what? So let me make the calculation very simple. Okay. Anyways, here also I have a 7. Here also I have a 7, right? So 21, 28, both the sides I have a 7. So I will remove that 7 square outside. When I remove the 7 square outside, it comes as 7 itself. Simply 7. Okay. Now inside what I will be left with? I will be simply left with 3 square plus 4 square. I hope you understand this. Because from 21, if I remove a 7 square, I will get 3 square. Same from 28, if I remove a 7 square, I will get 4 square. So that 7 square is what is coming out of the root as simply 7. Okay, yes. So now this is equal to 7 into, you know very well, root of 3 square plus 4 square will be root 25, which will be simply 5. So that means 7 into 5 will be 35 centimeters. So I got to know that this AC is 35 centimeter. That AC is nothing but the diameter of our semicircle, which means the radius will be 35 by 2 centimeter. I mean, radius of our semicircle will be 35 by 2, half of that. Radius will be half of the diameter, right? So 1 by half of 32 by 35 by 2 centimeters. So this is going to be the radius of our semicircle. Now what about the area of the semicircle? Area of a semicircle will be half of that of circle. So half of pi r square. So half into 22 by 7 into r square. Just now we found r. So 35 by 2 into 35 by 2. Okay. R square it is, don't forget. So that's why I am multiplying for 2 times minus finally. Okay. Finally what we have is, now we have the quadrants area also. Correct. Okay. I think we will not have enough space here. So I'll put it in the next line better. So minus. Now what about the quadrants area? Quadrants area will be 1 by 4 of 1 by 4 of pi r square, is it or not? So 1 by 4 into pi is 22 by 7 into, what about that quadrant's radius? Quadrant's radius is not a big challenge at all. See, this quadrant is drawn with what value as radius? With BC as radius, correct? So that means with BC as radius means, what happens? BC is already 21, we know that. It's there in the question, we also noted it here. So that BC will be the radius. So 1 by 4 into 22 by 7 into 21 into 21, that's it. Okay, so that means triangle area plus semicircle area minus quadrant area. Now when I complete this calculation, I can easily get the answer, but it seems like the calculation we should be very careful. So let's try doing the calculations very carefully. So yes, fine. So I'll try to minimize the space. So we'll try to do the calculation very carefully. So first of all, this 2 and 28 will be 14 times. 14 times. So that means I will be getting 21 into 14. So what will be 21 into 14? So 21 into 14 will basically give you, it will give you, so 4 I will have. Next I will have 2 4s are 8, 1 1s are 1. So 9, 2 1s are 2. So 294. This is done. 294 will be coming here. Now plus, now what about here, this structure? Here I will be having, I can cut 1 2 with 22, I will have 11 times, and I can also cut 1 7 with 135 for 5 times. That's all I can do. I cannot go further. So here I will be having 11 into 5 into 35, correct? 11 into 5 into 35 by, here I have 2 2s are 4, correct? So I have 4. So 11 into 5 into 35, we need to do it carefully. So these calculations is where we need to be very careful. So first of all, I will multiply 5 into 35. So 5 into 35 will be 175. So I will separately multiply this 175 into 11. So this will give you 5 plus 7 is 12, 1 carry, 1 plus 7 will be 8, 8 plus 1 is 9, and then again a 1. So 1925 by 4. Okay, fine, yes, because 2 2s are 4. That's how this denominator 4 comes. And then minus. Here will come here. Here also I can cut 1, 7 and this 21 for 3 times. And next I can also cut 4 with 22. Here 2 times, here 11 times. That's all. We cannot go further. That's it. So now I will have 11 into 3 into 21. So 11 into 3 into 21. First of all, 3 into 21 will be 63. 63 into 11 will be 3 here, 6 here, 6 plus 3, 9 here. Simple. So 693 divided by 2. I will have only 2 here. Done. Okay, because all the denominator terms are cancelled. So now I need to simplify this further. So it's again a challenge, right? So 294 plus, so what about 1925 by 4? 1925 by 4 will be, let's do it very carefully, okay? So first of all, 4 4s are 16, balance is 2. Next I will have 4 8s are 32, and then I have a 5. 5 means 1.25. Okay, it's because 5 by 4 will be 1.25, that I have put it here directly, minus here 693 by 2. So this will be how much? 693 by 2 will be 3, and then I have 4, right? So this will be 4, because 2 4s are 8, balance is 3 1 13 13 means 6.5, so that is 346.5. so this is what we are getting. Now when we try to simplify this itself, we will be getting our answer in terms of decimal only, and exactly we'll get our answer in 2 decimal places. Okay, yes. So how to do this? Okay, first of all I will add these two numbers, or any other easy way to do this. No, we must do this, no other way to escape and all, we have to do this. So this is where we have to be very careful. Okay, so first of all I will add these two numbers. When I add it, I'll take this space. Okay, so if I add this, I will be getting I can simply add these numbers, right? Because this is 294, right? If I give a 6 here, this becomes 300, and if I remove a 6 here, this becomes 475.25. so I will have 775.25 minus 346.50. that's all. I need to do this calculation to get my final answer. So this becomes 125. I will make this as 4, and this becomes 125 minus 50 is 75. So my answer will end with 0.75. Now I have 4 here, right? So 4 means I will make it as 14, so that this becomes 6. So 14 minus 6 will be 8, and then 6 minus 4 will be 2. 7 minus 3 will be 4. So 428. So 428.75 would be your final answer. Let me check it again carefully. 14 minus 6 is 8, and then this will be 6. No, so yeah, 6 minus this will be 425. Yeah, exactly. 74, 75. Okay, yes, okay. So this will be 2 and then 4. So 428.75, and along with the units, centimeter square. This will be the final answer for your question number 20, subdivision B. Now we are with question number 21, the last problem of this exercise. So here the question is, in the figure, a chord AB of a circle of radius 10 centimeter subtends a right angle at the center O. So that means here they come to tell there is a circle. There's a circle, and whose radius is going to be what? Radius is going to be 10 centimeter. That is also given there in the question. So O is the center of the circle, and A and B are 2 points on the circle. That means OA will be 10 and OB will also be 10. This is very clear. Now there is a chord AB. Okay, AB is a chord. Okay, remember, a line that joins 2 points inside a circle. Such a line is what you call it to be a chord of the circle. So here in that sense, AB is a chord. Now this AB is making or subtending an angle of 90 degrees at the center of the circle. That's what they come to tell. That means the angle O will be what? I mean, this AOB, this angle will be a right angle. That is, this angle will be a 90 degree. So it is very clear that there is a sector formed. OABC, there's a sector is formed, right? So OACB, a sector is formed. Now see here, the question is, find the area of the sector OACB and also that of the major segment. Okay, fine. So that means we need to find the area of the sector first, and we need to find the area of the major segment. Okay, we'll come to that major segment little later. First we'll finish off to find the area of the sector first. Now just observe the sector alone. Okay, now the sector is basically what? It's very simple to understand. Since this angle is going to be a right angle 90 degree, it is very clear that this sector is actually a quarter circle, which means I can easily find the area of the sector, which will be 1/4 of pi r square. Correct? So 1/4 of pi r square means here in our question it is advised to take pi as 3.14. So let's use the same. So pi 3.14 into r square. What about r square here? So r square will be, r is basically 10 here. So r is 10 centimeter. So 10 into 10. So this is what we will be having. Is it or not? Yes. Okay, fine. Now when we simplify this, we can easily get the answer. Let me do a small thing here. I will directly cut this 4 and 3.14 itself, because I have 10 into 10 will be 100. It will be easy for me to multiply 100 with a decimal number. So I am cutting these numbers. Okay. So this will be actually how many times? First of all, I will have a 0 point. Now I can consider this as 314 itself. So 31 by 4. I can go up to how many times? 7 times. 4 sevens are correct. I will go up to 4 sevens are 4 sevens are 28. 4 sevens are 28. I will have a balance of 3. I will have. So balance I will have 3 means now I have how much I have 34. I have 34, right? So I have 34 means again I can go up to 4 8s are 32. 4 8s are 32. Balance I will have 2. Again further I will have 2. It means like 20. I have a balance 20 because it's like decimal. After that it will be zeros only. So 20 means finally 4 5s are 20. So I will finally have 0.785 into 100, because 10 tens are 100. Now you can easily multiply these numbers. So when I multiply this decimal into 100, my decimal point gets shifted to 2 decimal places. So I will have 78.5 centimeter square. Now this will be the area of our sector. Now this point is very clear. So this part is done, very clear. Now we will come to, they have mentioned something here called major segment. Find the area of the major segment. Now what do you mean by major segment? Now we will concentrate on it. Okay. Now if you see here, I have just shaded a region here. Is it or not? I think you are able to see that region which is shaded here in this question. What I have shaded here. Now that portion is nothing but the portion is inside that sector, but it is outside the right angle triangle AOB. Are you able to see this? Correct? That is what you call it to be the minor segment. Understand? Okay. The portion that is below the triangle but inside the circle or the sector is what you call it to be the minor segment. And whatever portion inside the circle which you see above that minor segment is what is called the major segment. That's it. Okay, fine. So that means if I want to find the area of the major segment, what simple thing I can do here is I will take the area of the full circle. Now from this I will just subtract this minor region, minor segments region. Okay. So full circle minus this minor region will give you the major regions. I mean major segments area. That's all. Okay. So this is going to be the plan. But in turn, we basically need the area of the minor segment first. Correct. So we need to find the minor segment. I mean this shaded region, first of all, we need to find. Only after finding this, I can use that here to get the answer, right? So for that reason, what we will do now is first we'll concentrate to find the area of the minor segment. How to find a minor segment? Very simple. Just now we saw the construction, right? This minor segment is nothing but the area inside the sector but outside the triangle. So for that what I can simply do is I will take the area of the sector. From this I will subtract the area of the right angle triangle AOB. So area of the triangle AOB, I will minus this. If I do this, I will be able to get the answer. Okay. Now already we have the area of the sector. This is going to be what? This is going to be 78.5, correct? So 78.5 minus that side. What about the area of the triangle now? So area of the triangle is going to be, of course, this is going to be a right angle triangle, a right angled isosceles triangle. So we can simply do half into. Now what about base and height of our triangle? Whenever we have a right angled isosceles triangle, the equal sides themselves we can take it to be base and height. So half into 10 into 10. That's it. Now once I do this, I will be getting 5. So 10 and 2, 5 times. So this will be simply 78.5 minus 50. So this will give you 28.5 centimeters square. So successfully we got the area of the minor segment. This is going to be 28.5 centimeters square, which is the area of this portion alone. The one which is shaded here. That is what is 28.5 centimeters square. Now next is we need to find the area of the major segment. Major is as per construction circle's area minus minor area. Okay. So what about the area of the circle? That also we can easily find it. Area of the circle we know very well, pi r square. So pi r square means 3.14 into, because it is advised to take pi as 3.14 in the question itself. 3.14 into r square. What is r? 10. So 10 square. 10 square means, yeah, 10 square is 10. 10. 10 square, and minus this is 28.5 minus segment, just now what we got it is 28.5. Now we will do this calculation also a little bit carefully. Why? Because here we have decimals. Okay, now it's easy to perform this calculation. 3.14 into 10 square is 100. So what happens when I multiply 3.14 into 100? It will simply become 314 minus 28.5. Is it clear? That's it. Okay, yes, fine. Now finally what I have to do here is I have to do this subtraction very carefully. So how I can do this calculation is, how to do it? Okay, we'll separately work it out. Okay, so I need this space. Let me take this space. So 314.0, I will take it like this. From this I should do minus 28.5. So how can I do this? I will have first of all I will just take this as 10, so that this will become 3. This becomes 3. So I will have 10 minus 5 to be 5, and once again I will have this to be 13. Okay, this will be 0, this becomes 13. 13 minus 8 will be again 5, and finally I have 30 minus 2 to be 28. So 285.5 centimeter square. Okay, yes, success. So area of the sector is going to be 78.5 centimeter square, and area of the major segment is going to be 285.5 centimeter square. These are going to be the answers for your question number 21. So yes students, this session we have completed successfully. This exercise 4.1, we have completed all these 21 questions. I hope the approach, the way, the steps, whatever we have carried out here to solve the problems, everything is clear to you. If any doubts, you can post it in the comment box, or if you expect any other exercises also, you can just post it in the comment box. I will see to upload those exercises also. I know I'm taking more time to make the videos and post it. I am able to see all your comments and everything, but still because of the other classes I'm unable to concentrate on this. So I really apologize it from my side, but I will try to do my best to and then contribute it to you. So yes, so like all these concepts and everything is clear to you, I think. And yes, again we'll catch up with some other exercise problems or concepts in the upcoming videos. See you soon there. Thank you for your kind patience. Thank you. See you in some other video. Yes, take care. Bye.